I think in the paucity of time, I'll start. Those who are outside, we're trying to push them in to come as much quicker as possible, but I'll take a couple of minutes and start. So good morning, everyone. My name is Ahad Ahmed. I'm part of the organizing team here at ZAC. I'll quickly introduce the ZAC World of Facade Conference Series, and then we'll get straight into action. This is us. We've been organizing this conference series since 2012. It's been a while. We've finished around 222 editions in 51 countries around the globe. I'm from Chennai. Everything's executed from our office in Alwarpet. So we've been able to take this conference from here to different countries. Of course, the way facades are designed, engineered, installed are completely different in different regions. But for us, it's been an Albania, Georgia, Uzbekistan. I mean, these are all holiday destinations, but there's a lot of construction happening over there. These are the places where there's a lot of buildings which are being built, and they probably are doing many more new builds than most of any major European or American city. So these are the hidden places. Very less awareness on facade engineering. So we went there with our entourage and brought this conference series there, and it's been exciting for us. This is our lineup for 2026. Lots of new places. We went a couple of places we've gone and returned. Cyprus was a couple of weeks ago. North America, we have a strong presence. So this is what we keep doing. Chennai is the third time. I think we did our last one 3 years ago, and then the one before that was in 2013, which is 10 years ago. Architecturally, it's not a very exciting place for people to come to Chennai, but because being from Chennai, we are able to force people to actually come and support this conference series. And I'd like to start off by thanking our event partners, starting with Shooco. So Shooco is a world leader in aluminum door window curtain wall systems. They've been present from the last 14-15 years in India, and they are market leaders in this segment. We'll start, then our powered by partners Aluplex. Aluplex is a leading facade contractor based out of Mumbai, Hyderabad, operating nationally and internationally. Then our associate partners Assa Abloy. Assa Abloy is a big Swedish group. The division participating is their automatic doors, revolving doors, entrance solutions division. Dow is a global leader in sealing and bonding solutions. So Dow is one of our global partners, being present with us everywhere. Fundamax are an Austrian company, very popular in the Indian market. Product is HPL, high pressure laminate. Don't need to talk much about them. It's a well-known product now. So they have been a part of this conference series since its inception in India. Grestas Unitas, GU, short name, is a German company. They're into hardware solutions. So these hardwares are for doors, windows, for curtain walls, different solutions. Innovators is another leading facade engineering company operating nationally and now very soon internationally. Qtone, known more for their ceramic tiles for flooring and sanitary ware. These same ceramic tiles can be used as an external cladding solution on the facade. So people are moving away from composite panels and moving to ceramic and other cladding materials on the facade. So Qtone is now trying to push the ceramic cladding revolution in India. Rockwool is basically stone wool insulation. Stone wool is used in a lot of places, and biggest properties of stone wool are fire protection and thermal performance. So Rockwool, a Danish company, are global leaders in that. Technoform is a German company, so they've got thermal efficiency solutions. You would have heard of thermal break in aluminum windows. They've got another solution which is basically a warm edge spacer bar, which reduces your U values in your units. So Technoform would be presenting a little later today of what that is. Viva is Indian manufacturer, started off as aluminum composite panels, but now are having other cladding solutions. They're launching their solid aluminum cladding today. They have a talk later in the afternoon. Of course, our events are based on our original introduction to this industry with the glass doors, windows, and aluminum extrusions exhibition, which we alternate between Bombay and Delhi every year. So this year the show is in Delhi. We're going to Yashobhoomi for the first time, which is I think one of the most modern convention centers India has ever built. So we're going over there, and that's 10th to 12th December later this year. Our next event is in Bangkok, so that's a month from now. That's our 4th time or 5th time going to Bangkok. We go to Delhi next month, Mumbai, which is our let's say flagship event in India. That's in October. And of course, the events we've recorded, not everyone is able to spend the whole day, which is fine. So we are recording all the presentations, and all the presentations which we have permission to share with you is on our YouTube page. It'll take us 7 to 10 days to upload it. So you can follow our page and you'll get a notification when the video is uploaded, or you can wait for an email from our team. They'll send you a link directly into your inbox. So this is us. Doing these events all across the globe. It's been a while, the 222 editions. On an average, last few years has been 32 events around the world. It's all storytelling, and I think today we have variety on the program. We've gone for design this year. Last time was more heavy on engineering. This time is more on design. We've got 4 different perspectives. Of course, we've got the facade consultants talking more on the engineering, more on the performance of the facade. We've got a couple of panel discussions on that. But we've got 4 different architects. We've got a local architect, we've got a national architect, we've got an international architect based in India, and then we've got an international architect who's come. So 4 different perspectives, all have different stories, different projects to share, and I hope you'll enjoy today's storytelling. That's it from me. I'd like to call upon our event host for today, Ankita Bob. So she's an architect. She specializes in computational design, again, a very specialized topic, something we're exploring to bring to India very soon. And then I think with AI now coming in, computational design and AI, that's something which is what we will launch very soon internationally and then bring it to India. But she has studied in Barcelona. So computational design is going to change the way we design buildings. And of course, with AI coming in, the whole ball game is going to change. So you had earlier architecture, engineering, construction. You're going to have a 4th module of operations, and then you're going to have the 5th module, which is basically regeneration. So India has not yet gone into that regeneration cycle, but it's soon going to come once people start asking for carbon calculations, embodied or operational carbons. Then monitoring the whole building is going to become a big ask, and I think AI is then going to help. So right now people are talking about AI just for creating let's say animations and creating let's say 3D rendered image, but I think the actual usage of AI in the construction industry is going to come when you actually calculate the operational performance of a building and what you can do with that and how you can improve it 10 years, 5 years, 15 years after it's built. So that's a topic for some other time. Today we stick to facades. Over to you, Ankita. Thank you.
Hello. Yeah. Thank you so much, Ahad, for that introduction, and thank you for providing a strong start to today's conference. Very exciting to be here. Good morning to everyone, ladies and gentlemen, and welcome to ZAC World of Facades 3rd edition in Chennai and the 223rd global edition of this conference. First of all, thank you so much, all of you, for being here with us. It's a very exciting lineup for today. It is my pleasure to be your host for today. My name is Ankita, and like Ahad said, I'm a computational designer, and I lead design and technology at CATA, where basically we productize construction. And to push this further, we've partnered with Withworks, a Korean engineering and architecture firm, where we pioneer design for manufacturing and assembly. And they have worked on many projects, complex designs from design to physical reality, with helping firms like OMA, MVRDV, etc., realize some of their most geometrically complex projects across the world. So more on that later. I would love to talk to all of you. But yeah, like I said, We have an exciting lineup of speakers today, along with a very interesting panel discussion. Before we go into today's program, may I inform you that we will not be taking questions for the speakers during or after their presentations, but of course the speakers will be available and around in the networking area later, where you will have the opportunity to speak with them. And also kindly keep your phones on silent so everything is smooth and clear. All right, I think we are now ready to welcome our first speakers of the day. Please give a big round of applause and welcome to the stage Ms. Nasira Razak and Mr. Aditya Goel from Gensler. Welcome. Hi.
Good morning, everyone. Firstly, thank you for making time on a Friday morning. We're really happy to be here and have all of you as audience. So today, whilst we have curated our session across these 5 sections, and we're going to talk it through the lens of what workspace and commercial buildings and campuses, are looking like. But I think the biggest thing that I want you to take away from this session is how meaningful design ends and begins with human experience, right? And that's what our biggest, I guess, the whole premise of this topic is around that. Now, before we get started, I just want all of you to take a moment, take a pause, and think about your favorite childhood memory. I can speak about mine. For me, it was always the summer vacations I had at my granny's place. Right? When I think about it, it's all about how my cousins used to get together. We used to run across corridors, go out into the garden, pluck fruits from the trees. And to be honest, if I look back, I don't really remember the dimensions of the room, what the height of the ceiling was, what the tile looked like, what was the color. But yet, every time I see a mosaic tile that's similar to that house, in an instant, I go back to that place and that time. And what I get engulfed in is with that feeling of warmth and that carefree life I used to have. So what is it that's saying? It basically talks about how everything that we design impacts the human experience that we get out of it, right? And that's what we're going to talk about today, how design has that opportunity to impact human experiences. And ultimately, all of us here are nothing but an amalgamation of all the experiences that we go through our lives, right? And design, as designers and architects, we are at the premise of ensuring that everything we design, we are creating a positive impact on everyone who's experiencing the spaces that we're creating. So at Gensler, we really believe in research-driven design, right? And 18% of our profit every year is invested back into research. So we have an institute in Gensler called the New York Institute of Research. And all through the years, all they do is research around topics across the industries from the lens of design. And we come out with a publication called the Design Forecast Live. That's something that's out there for all of you to access. And what it really talks about is the future trends that it's seeing across the globe, across industries. And today we're going to talk about what's shaping the future of design. And there are these 5 trends that Gensler's Design Forecast 2026 is talking about. And I'm going to just walk you through the 5 of them that they're speaking to. The first one, this one is pretty interesting, especially because we're talking about experience design. It says that people are paying premium for experience. What does that mean? It means that India, being an aspirational country, we are a very fast-growing economy. People now are willing to pay for more than just the basic experience, right? We are a very young country. Our average age is 29, right? That makes us probably a big demography with a lot of youth. And this youth has flown across countries. They have experienced the best of the best. And when they come back to India, they want to experience that global level of experience in everything. And even when we're talking about workspaces, that's what they're looking for, right? The idea that amenities is no longer just about providing a gym or a basic cafeteria. They want that high level of world-class office spaces while they're working in India. And then the race for high-value talent. India is where everyone's coming, right? All the workspaces that we are now designing are for global firms. You're talking about Microsoft, Google, everyone's here and they are setting their footprints here, right? So what does that mean? Everyone is actually looking and competing for the same set of talent in India. And like I just said, we have immense amount of young workable population and every global firm is fighting for the same talent. So it's becoming increasingly important that the real estate that they're building for this demography is something that they're going to retain them for, right? And what these employees are really looking for is not just having a good workspace that lets them work for 8 hours. It's about the lifestyle that they're going to get while they're spending that 8 hours in that workspace, right? So it starts primarily right from the entry to the campus to that journey they take to their workstation and how that day-to-day looks like, right? So it's becoming increasingly important that as designers, when we design workspaces, every person who's entering that office not just identifies itself to the workspace they are in, but it also needs to speak to the brand that they're working for. And you know that every generation has had different expectations for their workspaces, right? When we're talking about, say, baby boomers, at that point, hierarchy was very important. It was about having that corner office. You know, success meant that. When we spoke about, say, the millennials, it was more about having that whole idea of work-play balance. That's when the Googles and all of them came back. And we were talking about having foosballs in the workspaces and all of that. So that was the expectation then. But now, when we're talking about the Gen Zs, they are looking a lot about purpose. For them, it's important that when they're working for a firm, they need to feel that they're part of a larger vision, they're part of a larger purpose, and that's what makes them stay in a firm, right? So the workspace that we design needs to speak to that. And we really believe that office spaces and campuses are nothing but canvases that communicate that brand immersive story to the employees that they're valuing for. And then, of course, India, we are probably the fastest growing, third largest economy in the world. Like I said, the dearth for talent is so much here. And the fact that the biggest shift India is seeing right now is it's no longer seen as a cost arbitrage market, right? For the longest time, we were that country where people used to do back-end work. It's no longer the scene, right? The global firms that are setting up offices here, they are looking for talent that are helping them with research, that are helping them with innovation. Even if you look at all the biggest giants, an Indian is representing the leadership there, right? That's the moment we are in. And hence, the workspaces and the campuses that we're designing for is for this set of talent. So office spaces are also evolving. It's no longer about, you know, even when you're talking about real estate returns, it's no longer about efficiency or metrics of that sort. It all is boiling down to the experience. Experience is becoming actually the most important parameter to decide the value of a real estate. That's the biggest shift that we're seeing, right? And how experience translates into tangible workspaces is what we as designers do. And the fourth one, somebody just spoke about how AI is coming to the picture. The digital world is an integral part of our lifestyle, right? So when we are talking about having an experience or generating or creating a positive experience, it is an amalgamation of the physical, digital, and human experience together. What does that mean? It means that the digital world is becoming such an integral part of our lifestyle that integration while we design is becoming a pertinent thing that we need to look at. And it's all about how we are making sure that the interaction that happens between an employee while they're in office, it's happening so seamlessly that you're not even realizing how I'm going from one place to the other. What is it that's nudging me to go there? It all happens through intentional design. And we can talk about a lot of instances where, for example, when we say design a work plan, right, for an office, what we do is, even whilst the building is coming up, we all talk about the fire escape staircases, right? That's one dead space that usually is in the building and it's used only for, in case of emergency. But when we go and we change that core wall into a fire-rated glass, suddenly that staircase is visible, and suddenly people use it, right? So it's that low intervention, high impact nudges that we do, so that the employees are having a reason to go up and down, and then we plan destinations in a way that there is a reason for them to go there. So these are the kind of, I guess, planning interventions that we're talking about that sort of adds to the experience overall. And this idea, like I was saying, every generation has had different expectations for their workspaces. The one thing that we're seeing more and more right now is today's workforce really needs that flexibility of choice when they work, right? They want to work anywhere, anytime, and in a way they want to, right? So which is why it's becoming increasingly important that the layers of hospitality, the layers of amenity is becoming extremely crucial when we're talking about any campus design. The idea that they should feel connected to any corner of the space at all points of time. And that is where your structural aspects of the building, the facade, how that gets designed becomes an integral portion of ensuring that the experience that the person has while they are in that office is seamless. And we're going to talk a little more about it in the later slides while I hand it over to Aditya.
Hi everyone. So we at Gensler, it becomes very important for us to really understand the human context while we're designing human-centered building. So what has really happened in India in terms of the evolution of GCCs, I think this is a topic that has been kind of viral in the last couple of years, but there was an evolution that was happening from the 90s. So in the 90s, we had our tech parks with the ITES services coming up. So we had the evolution of tech parks. We saw these large Infosys campuses, Wipro campuses, these tech parks as closed network of offices. And that's how it began. The second wave was they started thinking about how they can actually become live, work, and play destination. So you started seeing more residential things coming near to office campuses, more entertainment-led things coming up. But this was just the starting, and it was still a closed-door campus that we were looking at. In 2010, lifestyle became important. This was also the time when people were hiring more knowledge workers. As Nasira was saying, that there was aspirational talent that was coming in, and they wanted or they were seeking lifestyle. And now I think what has happened in they're almost like mini cities. So the idea about everything all at once. So you can do entertainment, you can do residential services are there, you have retail services, you have health and wellness. So it's everything that is happening within that ecosystem, and it is no more a closed ecosystem. You have mixed use open campuses that are coming up throughout Bangalore, throughout India right now. So this is where we started looking at the next level of evolution when it came to buildings, and you will see the facade, the design kind of responds to the changing requirements of the building with every era. What is really happening at a level of employees, at a level of human experience? So one interesting thing is that the jobs are becoming more and more, they're not permanent. So I think 20 years down the line, people used to, choose a job and be in that job for 20 years. But now 91% of the millennials expect to stay in the job for less than 3 years. So the talent, it's a big thing to retain the talent, and for that, you need to respond to their requirements. Employees need to socialize in the workplace. There's more rise of socialization. There is more rise when it comes to hospitality-led amenities within the workplace, the cafeterias, the wellness amenities that you see. They are not less than any hospitality experience that you have elsewhere. In terms of the choices that the workplace provides, so the idea is that the employees are more mobile within these campuses. They are doing more things, and they're working from different locations. This is having a sort of a marked difference in how we design the buildings now compared to what we used to do 20 years back. And there is more and more research that all your tier 1 companies, your Microsoft and Googles, they understand if they don't invest in their employees, they're not going to grow. And there has been a lot of study when it comes to your profit, your revenue. The more a company is investing in their employees, they are sort of getting the returns in terms of profit and revenues.
So we have 3 case studies that we'd love to sort of showcase where we are sort of translating everything that we spoke about into experience, into actual buildings. Now, this one, I'm not sure if you've seen this before, but this is the NVIDIA headquarters that Gensler designed in California. And the ethos of NVIDIA is that everything was centered around its people. That's what they say, that, our people are at the heart of everything that we do. And so when we designed them, this headquarters, that was the core of everything we did. So there's a short video that we're going to showcase. And what you'll see is from the facade to the structure to the interiors, everything speaks to each other, right? So this whole idea of inside out. Now this, this is a workspace, by the way, right? And you won't see your typical meeting rooms and, those walls is what is missing in this whole building. And that's what's really adding to the experience that it is. The idea is that, this went beyond departments and rooms and meeting rooms and collaboration spaces into making it a cohesive building such that people could walk anywhere at any point and collaborate any which way they wanted. And it was all meant for people from all walks of life, all personalities. And every corner of this building was utilized in a way that any person, from whatever capacity they're coming from, they have the choice to work the way they want. So again, like I was talking about, this whole idea of blurring boundaries from outside, and even in the way the facade was designed, if you see, that porousness that you get from, even sitting inside, you're not really feeling like you are enclosed in a building. That was the essence of how this design happened. The idea that, people could work outside, they could work inside. The idea that you could make adaptable work settings, that was a big way this whole thing was designed. In fact, the building structure was also inspired by the chip, right? And how interconnected those are and how that can be then translated to the workspace itself. And we had these pockets of green spaces all across spread. So the essence of it being that, design can really, really inform how people's behaviors work, right? And that's a big, I guess, takeaway that we would all want if there are designers and other creatives here. The idea that everything that you put on paper has an impact to create a positive or negative impact on people's behaviors is something that we need to keep reminding ourselves of. And this building was a great example of how it nudged behaviors of the people that were using it inside. So that was case example one for us, and Aditya is going to take it to the next one.
This is a confidential client that we were working with, a developer. So in 90s, they developed an IT park, and they came to us. They wanted the IT park to be relevant in 2020 as well. So it was in one of those locations, which was prime location in Bangalore, had the best of the clients during that era. But there were a lot of complaints that were happening from a tenant perspective, where they were saying that the campus is not really responding to the aspiration of their employees. So that is where we started looking at, and the first step that we really took was we didn't give a solution. What they wanted us to do was just amp up the amenities, and that was their solution. But we said, let's take a step back and really understand what the problem is. So what we did was we did a feedback analysis, we did a survey analysis, we took surveys of the tenants over there to understand what are the employees really missing. And we really took a whole journey within the campus where we had feedback at every junction of an employee's journey and what were they feeling about the journey overall. What we really understood was that they are not just missing the quality of the building, the facade, but what they were really missing was that they were not able to do multiple activities when they were within the campus. So what our solution was to really sort of transform this closed gated IT campus into an open mixed-use building. Typically an IT campus is utilized 9 to 5, Monday to Friday. But when you looked at a mixed-use building, it is 7 days a week and has at least 12 hours of utilization that happens throughout the day. So it leads to more activation, more business, and sort of more profits and more revenue for the builders. So the first thing that we really did was take out the boundary wall and really integrate the central courtyard that you see within the flow of the journey. And from the A, that was the initial touch point we had. You had a very formal entrance with a gate, and you used to enter the IT park in a very formal way. But what we did was we took out the entire wall and made this into a centrally entry sort of a campus where you utilize this courtyard and that becomes your first touch point. And what we did, we activated this whole central courtyard into a very mixed-use building. We brought in retail, health, wellness, entertainment. So there's a theater now where you can have stand-up comedies and things like that. So it sort of, answers to different requirements of employees throughout the day. So this is what we did. This is how we changed the whole journey. We figured out what's going to happen in this particular layer and how it's tying up to employees' cycle of 7 days a week, and sort of making sure that from the first gym till the last entertainment that they want through their day, everything can be answered within the campus, and you can have more people entering the campus other than just the employees. So when we started looking at the whole activation of the campus, what it meant for us was also looking at the experience from a perspective of facade, from a perspective of landscape, which really gels in to the experience that we're talking about. So this is how we activated the facade. So there was a digital layer that we also put in the DXT layer. So how do you get that feeling of a mixed use, right? So you're almost entering a hospitality campus. Now this becomes a low intervention sort of a thing for us, but has a very high impact in terms of how it changes the experience. And from a very formalized, almost boring IT campus, how do you sort of get this layer of activation, vibrancy into the campus? That became a sort of a problem statement for us. In the second case study, again, this is something that we did in Calcutta. So how do you create an IT campus that can activate and respond to the local context? So what we are understanding more and more, the more global we want to be, we have to be more locally rooted. And that's where our building needs to responding to the local context, but in a much, much global way. So in this particular thing, we started looking at the ecological, terrain of Calcutta, of around that region. It is a home to the Ganga Delta, and you have amazing sort of landscape that's happening over there. We took that as an inspiration to really try to understand how that really sort of connects into the facade, all that meandering paths, the topography that you see, how that now starts connecting into the facade in a much more meaningful way. This is not just symbolic, but it actually becomes the place where people meet, where people step out. It becomes an activation layer. Just like you see the river sort of happening and meandering path, it really starts responding and gives a green sort of spine into the building in a very sort of a meandering way, as inspired by the topography of Calcutta. And this is what we finally created, right? Also sort of making sure you have activation in landscape. The landscape sort of responds, the facade responds to the landscape that we have created. So we really didn't want to talk just about the exterior of the building, but how it becomes a human experience, and everything needs to sort of gel in and respond to each other is what we wanted to really talk about through this case study. So in the end, so what we really want to sort of leave you with is how we create meaningful connections and enrich the human experience through the power of design. So that's something that we really believe in, and I think as designer, that becomes a big responsibility, how we enrich the human experience. Thanks a lot.
All right, thanks everyone.
Thank you, everyone.
Thank you so much for a great presentation to start our morning. And it's so inspiring to see that Gensler keeps the real familiar human experience at the center of design in an evolving and unfamiliar age of artificial intelligence. So for our next speaker, I would like to invite Mr. Ashwini Khanna from Fundamax. Please come.
Okay. Good morning, everyone. I am Ashwini Khanna. I am representing Fundamax. Before I get into thick of my presentation, which is about cladding in the coastal areas, I want to interact with each one of you. So, may I request everyone to open menti.com and please participate in this small survey. You can scan, or the Menti code is also mentioned on the screen. It's 4891 5975. I can see 8 people. So we have architects, consultants, fabricators. I do understand there are trade guys as well in the room. Builders as well. Thank you. I'll move to the next question. What do you consider the most severe challenge when designing building in a coastal city like Chennai? Yeah, heat, wind, wind load, yes. Heat and humidity is becoming bigger. So these are two important challenges what we face when we design buildings in coastal area. Humidity is, yeah, exactly. So it was 69% yesterday evening. Corrosion, people are talking about corrosion of metal. Yes, climate. Climate in itself is a challenge here when we talk about designing buildings in coastal area. Now, in one word, what is the most important factor for you when specifying a facade material? Namaste. Durability, climate, sustainability, these are the topics. So I think I can continue my presentation if these are the topics. Because when we talk about cladding with Max exterior panel of Fundamax, we are talking about addressing these topics. Let's look into the future as well. What are the trends you see coming up in next 3 years? In the facade technology. Digital facades, AI, parametric facade. I'm just reading some of the points which I can immediately see on the screen. Parametric metal facade. Yeah. Thank you for participating in this survey. Next part is a small video from my side. For massive kinetic and thermal forces. Wind speeds frequently exceed 150 kilometers an hour, driving torrential saltwater directly into concrete and steel. To survive these conditions, a modern architectural facade cannot rely on passive decoration. It must function as the building's primary line of thermodynamic defense. This infographic details the specific environmental stressors hammering coastal cities like Chennai. High temperatures, heavy monsoon rains, and saltwater air act simultaneously. This intersection accelerates material decay and metal corrosion at rates rarely seen in inland environments. Traditional steel building methods often fail because they lack a mechanism to exhaust moisture. Concrete absorbs water, and without a specialized escape route, condensation pools permanently inside the structural wall. Static barriers cannot manage dynamic coastal environments. The architectural response to this failure is the rear ventilated facade system, or RVFS. Our separation establishes an open, pressure-equalized channel that regulates thermal and moisture loads before they can affect the building's core. This exterior laminate cladding panel then attaches, fully enclosing the air gap. That gap powers a thermodynamic process called the chimney effect. Solar radiation heating the exterior cladding warms the air trapped in the cavity behind it. As that cavity air warms, it naturally rises and exhausts at the top of the system, pulling a continuous draft of cooler supply air in through the bottom. This vertical updraft physically removes heat from the inner wall, preventing solar heat gain from penetrating the structural insulation. Science specifications highlight the necessity for high
porous laminates, with moisture absorption remaining strictly below 8%. Additionally, the heat resistance module dictates panels must maintain dimensional stability across a 260-degree range, from -80 to +180 degrees Celsius. Even stable materials undergo physical changes during these temperature shifts. The panels will expand in direct afternoon sunlight and contract as temperatures drop at night. Engineering the substructure with a combination of fixed and sliding supports allows the heavy panels to shift laterally along rails without compromising anchors. Systems without these sliding joints, thermal expansion would generate enough shear force to warp the panels or shear the bolts. The facade's construction also dictates how the building handles the heat of an exterior fire. Size incident case study provides empirical evidence of how facade systems perform under localized fire threats. Notice this damage detail. While the exterior panel surface carbonized with respect to the building's front, localizing fire depends on structural stability. Because the panels held their position, the fire was denied the oxygen and space needed to expand. If the fixing system had failed, the fire would breach the air cavity, utilizing the chimney effect to pull flames vertically up the entire building. Fire safety relies on the integrity of these mechanical connections. Permanent placement of these blades through sun path analysis. Mapping the solar angle throughout the year is only achieved when material density, structural movement, and airflow are precisely calibrated towards a single unit. Final takeaway: high-performance coastal architecture requires a building envelope that functions as a calibrated engineered system designed for continuous ventilation, flexibility, and long endurance.
So rear ventilated facade system is one of the solution for all the topics what we discussed. Now we have 3 projects which we want to talk about as a case study. So double skin facade system wherein the Fundamax panel can be used as a screen to give heat insulation as well as thermal and visual comfort to the occupants of the building. So this is one project we have executed in Lucknow. And the next is you can look at horizontal as well as vertical louvers. The purpose is exactly the same, giving thermal and visual comfort to the occupants of the building. Here the louver angle is decided after studying the sun path analysis in detail. So the left building is actually the project in Kerala. This is also the project in Kerala wherein CNC cutting is done. This is the school project. It's basically the corridor. This CNC cutting allows some kind of sound insulation as well because it absorbs the sound and thereby also giving the ventilation to the building. Now, further, we would like to show some projects which we have executed. Okay, thank you.
Thank you so much for that interactive session. It was very insightful. We have our next speaker of the day with us here. So ladies and gentlemen, let's give a round of applause to welcome K.R. Suresh, who is the Regional Director at Advanced Facade from Mumbai. Please come, sir.
Good morning. Good morning. I think I have the first session now as a facade consultant to talk about only fire. And what we have actually done is last month I was moderating a session for fire itself, and there were key takeaways from that. So what we thought is, let us just show you what codes have changed. The NBC has changed to NBCS, but there are so many things other than that which I want to talk about in the presentation, and soon I have a video for that, just to talk about what I'm going to speak about.
fire safety, the right materials can make the difference between risk and protection, and in critical moments, they can help save lives. In today's presentation, we will focus on 3 key components that play a vital role in building safety. Materials, because the quality rating and compatibility of each material directly impact fire resistance and life safety. Technology, as even the strongest system, depends on the right accessories, fixings, and installation details. Testing, to ensure every system performs as expected under real fire conditions. Fire safety and compliance, the non-negotiables. National Building Code. National Building Construction Standards. The proposed NBC 2016 to NBC's 2026 framework is expected to significantly change fire and life safety compliance across India. The shift is from a purely prescriptive code to a more performance-based fire engineering approach with stronger digital compliance, evacuation strategy requirements, and accountability for developers, consultants, and facility managers. Documentation becomes more important, including test certificates, compliance labels, authority approvals, and installation records. NBCS equals safer design, stronger compliance, even though today we have access to the best materials, advanced technology, and tested systems.
Okay, so I'm going to talk more of beyond compliance. So I want to talk about what used to happen before and what is happening now, and what is the future. How do we change things? So this is the NBC code. I don't need to show it, I'm just showing it as a clip. But this is what NBC 2016 was. And if you look at, So if you look at this portion, is more to do with facades, where what is the openable panel required, what is the distance between the, where do you need an openable panel, how high it should be from the floor, everything is in the code. And everybody used to follow this. And I think what is happening is we only rely on a licensing person to interact with the CFO and get the permission. But what it actually says is that you can always go and come up with an option to the CFO, and you can always get inputs and you can change the design in terms of operable panels. And in terms of perimeter seals, in the NBC there was no particular chapter which told which spoke about that, and there were no codes available. We were always following international codes. So now this is the new NBCS code 2026, in which again the openable panels remain the same. It's just a copy paste. But if you look at this, these two codes have been included in this, basically for fire stopping and for resistance to fire barriers, and also more to do with testing. Like, I think testing has been more critical in this NBCS, where they've already put it in different chapters. So what you see is there is more impact in So there's big improvement in terms of perimeter fire barriers, especially for facades. I'm talking only of passive and a little bit of active measures. So if you look at this major improvement in terms of perimeter fire seals, there's been improvement in terms of penetration fire stops and combustible materials. So combustible materials, before we just used to even go for class B2, we go for any class of materials, and that was a big challenge. And there were no testing regimen which was already put in place. So because of that, what used to happen is people used to get any material which comes into the market, you just use it, and then if in case of fire, then there's a problem. And also the reference standards have changed in terms of, there are a lot of standards and codes which have been included in this, which makes it more viable for engineers, architects and developers to use it. But the only concern which is there is more of awareness. There is no awareness in terms of the codes. Everybody just follows certain line items, but they don't follow the whole thing. Like, there's a simple example of why the architect wants zero sight line. They don't want a zero, they want a zero spandrel. But then it also means that, why do you want to achieve that? It is basically depending on your distance from the building, from the glass building to the other building, and it's also the fire rating of the spandrel. So this is how a building behaves, just a curtain wall. This is a very schematic detail where you have a curtain wall and how it behaves in case of fire. So what happens is the aluminum, it softens up and it deflects. So what needs to happen is the fire should not travel from one floor to the other, or it should be compartmentalized. That's what we know about it. And we also have refuge areas and all that stuff, which is a separate thing. But if you look at this part, how do you take care of it is by a fire stop. This was what used to happen 15, 20 years back, where people just used to put a GI sheet and put some insulation in that and ensure that it's safe. Everything is okay. My building will never catch fire. So now the trend has changed. Now this is what the quality is. And there were a lot of fires which happened. And these are the recent ones. These are the recent ones which have happened. So this is to do with material in terms of combustible materials, in terms of perimeter seals, in terms of active measures like smoke vents. Everything matters. So it's not only about design; it needs to be considered in the design, and we need to take care of it. So a CFO, generally a fire brigade, the concern they have is how to evacuate people. Which in other cases, people used to go to the fire staircase. You have already got that, you have a pressurized staircase, but people want the CFO or the fire brigade to evacuate them. That is a concern. So they have a challenge in terms of breaking the glass. They have a challenge in terms of how do I reach that space. Now, as all these high-rise buildings are coming up, you have 300-meter towers, you have 200-meter towers. How does a fire brigade reach that place? And what needs to be done? So now the measures it's improved in terms of people have gone for a wet or a dry system, where they have a proper systematic approach, and they also the applicators responsible for it. So now it is not only the contractor, the applicator, plus the whole contract is provided like that for the project, and people are taking up responsibility for that. So now you see this, it's a more definite approach. And same thing with the dry system. So these are the different options which has come out throughout, in the due course of time, in terms of maybe 5-6 years. So before they never had, it was always a top bunk window. You always had a top bunk window as a smoke vent, and there was no, identification of what window, what is the distance between the windows and all that. I'm talking of maybe 10 years back, but now it has changed. Now the NBC says that, but still, you've got hardwares in the building, which for a high-rise building, it is going to stay for 25-30 years. And what about the warranties of the hardware? The hardware doesn't have a warranty, and the compliance says that. So you're trying to just contradict your own statement in terms of the warranties of the hardware, and trying to use it because you want approval for the facade. So you've got another option, where like if in Singapore also, you basically have these breakable glasses. You don't have openable panels for a high-rise building. So if in case in India, what you have is you have this panel. Oh, sorry. You have these panels. You have an openable panel, which is 1 meter by 1 meter, with a handle on the outside and inside. And it basically, it spoils the whole architecture, plus it doesn't serve the purpose. In terms of if it is a 200-meter tower, you can't reach that space anytime. And it also doesn't open when it is required. Your building doesn't catch fire every 2-3 months. It's basically once in a lifetime. So the hardware has to be equipped for that. And secondly, what provisions have been given now is for most of the buildings, you have actuators which actually become a smoke vent, which can automatically open in terms of the smoke alarm. But what happens here is every developer doesn't use it because of the cost. So the point is that we build something which we feel is nothing is going to happen to my project. So I think it should be an awareness where you look at a high rise and you think that it's 25-30 years, it's a premium project, and you need to consider everything which is required for that, or make it simpler. The other compliance now in this NBCS, they also talked about the cavity barriers, but not in detail. But this is very important in terms of all opaque facades. where you have aluminum cladding, you have stone cladding, you've got all these fixtures in the building, but nobody takes care of this. Everybody is just bothered of the curtain wall. So you try to always use perimeter seals, you ensure that you call the CFO, you tell him this is fine, but nobody talks about the opaque walls, where in case of fire, it can travel all throughout the building, and most of the fires which you saw before was because of that. It engulfs the whole building, especially in opaque area. So before this is what used to happen. They used to just put some of the buildings used to have an insulation which traps it, but it's not a rain screen. It's not ventilated. So what used to happen is there is water collection, then there is leakages in the building. So then the system came up where you have an intumescent, where in case of fire, the intumescent closes the gap and seals the gap and doesn't allow the fire to travel to the next other floors. So this is something which is required for most of the projects, but we don't do it. And we don't know which building is going to catch fire. So we had done a study 10 years back where I had given a presentation in terms of how do you ensure that, it is what do you say? It is basically, people follow it, or the developer follows the requirement of the CFO or anything. So what we did here was, it needs to be more to do with not only product certification, it's not only about testing, it's not only about using the right material, it's also about building the system. In terms of the government needs to put a body which actually inspects and ensures that the materials are all as per the codes or as per it is non-combustible. So if you look at this, in India what you have is, this is the code now, this is the NBCS, where you have a performance-based system, whereas you need to have a ban on materials which you can't use. Right now it's used. Right now, then it becomes a value engineering or it becomes a cost cutting in the end of the day. So you have this, and other thing is the fire performance of the facade system. It's not very clear in the codes. It is clear that there are materials which are non-combustible, but the systems are not. So if you have a curtain wall, it is not a tested system in terms of a curtain wall. It's a contractor is basically building up the whole curtain wall and then installing it. Nobody's testing whether it's meeting the requirement or not, or as per the codes. Third is building control. We don't have any building control. We don't have people. Actually, the fire brigade also doesn't have enough people to inspect all the buildings because we are so huge. So what you have is basically we need some building control which verifies each material on the building and also the existing buildings. Right now we are only looking at the new buildings. What about the adjacent building which may catch fire? So what we need to do is we need to educate, or we need to have bodies which basically look at all these aspects and not certify the building, or maybe give a notice to the builder or to the developer. And same thing materials. I think combustible ACP or PUR should be banned. But now all the ACP companies have started using corrugated aluminum, or they have started using, I think Viva is presenting the solid aluminum, which is good. I think that's a change which we should actually adapt. So this is what was the different aspects, but before it was A1, A2, B. That till there, the graph was still there. So I think we should change it to only A1 and A2, and we should change it to only, this is non-negotiable and no droplets. This is what we should have as a spec in terms of a base spec, and all the material should actually adhere to these parameters. So you have testing agencies which test everything. You got codes which are there, and you got certifying bodies also. But what we don't have is, we feel that our building never leaks and our building never catch fire. So I think we make a mistake, we should correct it. And I think since 10 to 12 years, we have been doing the same thing of building up awareness, but it's not changed to what we require. I think it's time that we change the way we think and we build our systems in place. Thank you.
Thank you, Mr. Suresh, for the innovation, deployment, and awareness on fire safety. Like you said, I think a lot of us think not my building, but that's not the case. It's definitely a big concern. We've had a couple of fires in Chennai lately also. Ladies and gentlemen, all right, we have 3 more speakers before our first networking session. Let's please welcome our next speaker, Mr. Shubham from Rockwell. Please come.
Hello. Yeah. Thank you, Suresh sir, for the insightful session. So you can consider my session in continuation for that. Before I start the actual presentation, I have a question for you to ask. Have you ever wondered what is common to all these fire-rated systems? If you take the example of perimeter fire stopping, fire-rated drywalls, metal sandwich panels, and many more. What do you think is common to all these fire-rated systems? Any guesses? Yeah, it's stone wool insulation. Stone wool is the commonly used backing material for all these PFP systems. It is the backbone to achieve the required level of integrity and insulation rating when it is required. So how stone wool contributes to the passive fire protection is what we'll be discussing in this presentation. Myself, Shubham, I take care of the business development and specification for the South India at Rocksool Rockwool. So this is going to be a flow of presentation. We will start briefly with the company's introduction, followed by the strengths of stone wool, focusing mainly on the fire resilience, importance of having a tested fire systems in the buildings, and we will also emphasize on how stone wool contributes to the building sustainability. And finally, we will end up by highlighting some of our solutions for various facade applications. So first and foremost, we have a major confusion whether Rockwool is a product or the brand name. So let me clarify that. Rockwool is a brand name. We are the brand owners of Rockwool. As you can see, it's a registered trademark and we represent the original Rockwool brand. In India, there is a lot of confusion. We often assume that any fibrous insulation is Rockwool. In order to differentiate from any other manufacturer, in India, we are known in the name of Rocksool Rockwool, and we manufacture a product called a stone wool insulation. Why it is called a stone wool is because we use volcanic basalt rock to manufacture and to protect the building from fire. Since we are an MNC, we are having presence in over 120 countries. We are having 40 factories across the globe. And moreover, we are expanding in India. We are coming up with our second factory in Cheyyar, Tamil Nadu, which is expected to inaugurate by next month. So we are eagerly looking forward to serve for the southern Indian market from our brand new factory. So if you take the case of facade application, we don't use insulation just for thermal insulation. We also use insulation to ensure fire protection, acoustic insulation, and building sustainability. What we at Rockwool are trying to do is we are trying to harness the natural strength of stone into our products. So these are some of the natural strength of stone by default you will be getting, which includes fire resilience, thermal performance, acoustics, durability of until lifetime of the building, moisture repellence, and 100% circularity. Recyclability also you can say. So in this presentation, we will mainly focus on fire resilience property. Among all types of insulation, Rockwool stone wool has excellent fire performance. It is a non-combustible A1 classified as per EN 13501 standard, which means it will not burn, it will not catch fire, it will not allow the fire to spread from one place to the other. It also has melting point of over 1100 degrees Celsius, which means when it is subjected to fire exposure during the testing, it can easily contribute to the system fire rating of 2 hours, 3 hours, and so on, right? And on the other hand, if you look at glass wool or any other polymer-based insulation, because it is having very less melting point, it will fail within 5 to 10 minutes of fire exposure during the testing. So when a non-combustible insulation like stone wool is used in a building, it can slows the fire spread, thereby providing additional time for building occupants to evacuate and allowing fire services to come and extinguish the fire. Ultimately, it will also save lives and reduce the damage caused to the buildings. Let's look at a short video on how our stone wool insulation protects you from fire and reduce the damage in the buildings.
I'm Nikhil here on D at Rockwool, and this is my farm from of the 7 strengths of stone and of course, in this case, the resilience against fire. He's also very passionate about his very first car, which he has had since he was 18 years old. He lost it a lot. Our cars are made using stone, which means their fire resistance to over 0.5 degrees Celsius, helping to stop the spread of fire. Which I'm happy to say, not only protects families and homes and friends and offices around the world, but also Henrik's classic motorcycle vehicle. Superior fire resilience is just one of the amazing 7 strengths of stone we harness in our products to enrich modern living.
So that was a short video. If we compare the fire performance of stone wool up against any other alternative material, we can clearly see that the stone wool is the only type of insulation which qualifies for the highest level of non-combustibility rating, which is A1 class. On the other hand, all the foam-based falls under combustibility rating, which is rightly highlighted by the Suresh sir also in the previous session. So an ideal, this non-combustibility nature of the stone wool insulation helps it becomes a default choice for us to choose for any passive fire protection systems. If we take the example of UK, after 2017 Grenfell fire incident, they have completely banned the usage of combustible material, especially for the high-rise structure. They are not allowing the use of B or BCD class beyond 11 meters height. So it's only A1 class certified material which is allowed to be used for the high-rise structure. To understand this gravity of this subject, I would highly recommend you to go and watch a documentary on this Grenfell Tower incident on Netflix, if you can spare some time on it. If you look at the different types of components of fire rating, we have integrity as well as insulation rating. An ideal fire rated system should have both integrity as well as insulation ratings to allow the safe evacuation of building occupants in the event of fire. And recently we have come across specification asking for rock wool to be fire rated. People ask 2-hour fire rated rock wool or stone wool insulation. Let me make it clear, no individual product like a stone wool or rock wool can give you an hourly fire rating. It is a collective system in the assembly which will give you an hourly fire rating like 2 hours, 3 hours and so on. So in most of the fire rated systems, as I highlighted, there are multiple products which are involved in the assembly. And these products are manufactured by different manufacturers during the testing. If you take the example of perimeter fire stopping, the system owners like Hilti, Fisher, STI, they collaborate with the insulation manufacturers like us for the spandrel and the smoke seal applications. And the same is captured in the certifications like UL and Intertech. So as we have highlighted here, they had used Rockwool's Curtain Rock 80 and Rockwool's Safe for the spandrel and smoke seal application. So it is our responsibility, and it's very important that we check with the system owner that are they recommending the same product and from the same manufacturer at the site level, so that we have the confidence that passive fire protection which is installed in the building, it will perform as we desire in the event of fire. And finally, the sustainability part, Rockwool Stone Wool adheres to the most number of sustainability scheme. You name it, we can help you in achieving the green building certification by contributing in the form of points, whether it is LEED, IGBC Green Pro, GRIHA, SGBC standards. All our insulation are also 100% recyclable, and we are offering recycling services in India at the ground level. So there are many customers in India who are already taking advantage of that. We are also having environmental product declarations in place. This could be handy for some high-end projects where client would be interested to understand the sustainability aspect of the product throughout its entire life cycle, right from procurement of raw material, processing, manufacturing, disposing of the material, right? And finally, one important certificate I would like to highlight is the EU CEB certificate. or USEP certificate. This basically is a certificate given to a factory to ensure that all the products which are manufactured from that particular factory are non-cancerous and biosoluble. Again, it's very important when it comes to the health and safety and when we are dealing with the mineral wool insulation products. We have wide range of stone wool insulation solution which are engineered for different facade applications. Of course, the facade curtain wall systems, metal sandwich panels, precast concrete sandwich panels, cavity wall insulation, double skin metal wall insulation when it comes to PV structures, ETICS or EIFS system for the external facade applications, ventilated facade. So if you are looking to have a more detailed information on this, please reach out to us. We have our stall here and we would be happy to answer all of your questions. So finally, I would like to conclude my presentation by saying not all Rockwool which are available in the market are from the original Rockwool brand. So if you are looking to use the best stone wool insulation from the original Rockwool brand, you can directly ask for Roxul Rockwool in the Indian market. So thank you for listening to me patiently. Have a great day.
Thank you, Mr. Shubham, for that. Let's now welcome on stage our next speaker, Mr. Yogesh Tantia from DSP. Please come, sir.
Can everybody hear me? Thanks a lot. A good session. We got to hear the architect's perspective, we got to hear the manufacturer's perspective, and you also got to hear the technician's perspective from a facade consultant perspective. Through this, what we are trying to put together is 4 case studies or projects that we are currently working. And with the venue being Chennai, we're trying to make it more regional, more centric. So 2 of the projects that we're trying to show are the ones which we are working in Chennai. They are at site right now. The topic that we try to put across is precision by design. What we are trying to put across is we make a fancy image, but to make sure that image converts into a functional building, a lot of precision is required in the design process and finally towards the execution process. So we are trying to say the gaps that we find today in trying to ensure that the design that we try to do are delivered with the same precision. And at the same time, what is required to be done on the design board to ensure that when it reaches the factory, the gaps are minimum. What I just said is set as pointers that we create form which creates a visual identity. There's a sense of scale, proportion, which becomes very important when you work with the fabricator to understand all the parts that go to build up the whole thing are taken care of. At the end of the day, it is somebody's campus or somebody's workplace which holds a brand expression. So that becomes very important for us, that the brand identity is also catered to. So we start with one which we are doing in Chennai in an area called Guindy. A lot of you who are local would definitely know about this as a location. So this was for a client who asked us that we want to deliver a bespoke building which is commercial but designed from a fact that it will be multi-tenanted, but designed such that it is an end user campus, which means anybody who comes to take this place should feel that it is designed for them and not designed, not keeping the end user into mind. This is the plan. This is a long linear building with a railway line at the back, and there is a metro line which is right in the front. The lower level is more public and the workspaces are taken at a higher level. Chennai has a good requirement of two-wheelers, so the section reads something like this. So what are we trying to put across as a problem statement? The front building, the front part of the building, which is known as B, the portion B, is an inclined facade, which is inclined in section and is also inclined in plan, which means the plan is changing continuously as you move up. The lower level is a 10-meter high glazed surface, which has this orange portion, which is a fin, which is changing in its section continuously along the curved facade. So these are the two challenges which we faced. These are the detailed section of how those spaces are coming up. The civil part of this is already built. A small video to understand the complexity that we are talking out over here. So what did we do? A typical system, we have the mullion inside and the outside is left open. We are trying to reverse the whole condition so that we don't duplicate the matter and you don't see anything from the inside. So we take the mullion out. How do you get the shape? So that's the plan at the lower level where the mullion is taken out instead of being inside. And the orange portion is the shape that we want, and the shape section is changing continuously, which means the gray portion is the constant portion, then the orange portion is something that we change. No two fins are alike in what we tried to do. We tried multiple systems. This is one system where we end up having this groove, which we didn't want. So what do you do as a solution? That's where we work with the fabricator. That's where we work with the facade consultant and say that, okay, this is what we try to do. Anything that we do, we don't leave it only on the shop drawing. There is a mock-up done to ensure that, and this mock-up is already done 6 months back. Tested for color, tested for the section, tested for the size, and hence a section which took a lot of engineering to get done. Chennai caters to a different wind load, but finally this is something that we were able to cut across. Left is something we didn't like, right is something that we are trying to go ahead. This is how the upper part of the facade is. So how do you make sure that the cross sections are taken care? A small video to say the testings that we try to do to ensure that all the sections are taken care of. This was the interesting part where the form is curving, and what do you do? We call it as a transition surface because the rest of the surface is a pretty much flat surface. This is where the transition is really happening. So that's the curve that you're doing, and the curve is happening, like I said, in the inclined facade also. So the technology which is very commonly available is obviously the cold bending, but cold bending we realize is something that we are still struggling in this part of the country to get cold bending done and installed. Not many fabricators are ready to go about doing it the right way. So this is one option that we preferred and we wanted to go about because there the geometry meets exactly and it is a factory finished product which comes. The second option was, which is the easiest one, just drew trapezoidal glass, but when you see it from a perspective of continuation of the facade language, it doesn't solve the problem. The third option, which is already done in the new Navi Mumbai airport, is do a facade which is having a curved profile, so you keep seeing these edges coming out, which also is something that we didn't want to go ahead. But what I'm trying to put across is different solutions to solve the same problem, but to get to the actual vision, it takes a lot of understanding of which system is suited. We tried all three and finally somehow managed to ensure that cold bending is the way forward in terms of, so what we are really getting at is to design the building and to ensure that the same gets delivered. It takes a long effort in terms of trying to engineer it the right way. A small one to show what it finally should come up like. What was also important finding, which is very relevant today in the buildings that we are designing in the city centers, the red line that you see going down is the metro line, and we are very worried about the acoustics that the building needs to cater to. And the railway line was obviously there. We did our findings in terms of what do we want to do. So there was a roadside problem and there was a rail side problem in terms of catering. Anybody will think that the rail side is a bigger problem to solve, but what we realized is the roadside is a much bigger problem to solve. And it was surprising because none of the buildings that we design today in city centers are catering to the roadside problem because of the traffic, because of the metro lines, and especially TOD related developments. So what did we do? Very simple, the air gap can be increased. So we increase the air gap from a typical 12 mm to 16 mm so that you increase the resistance. However, there was another option that we explored, which we went about, especially towards the roadside, where we did a laminated glass and not a normal glass, which means that you are adding a PVB layer so that the amount of layers that you are adding in order to ensure that the sound wave do not really enter is different, which means the building cannot have one simple solutions to go ahead with. it needs to have multiple solutions. And then this graph is trying to tell what amount of dB control is taken care in each of the lines. So the orange is one section, gray is one section, red is one section. What I mean by section is the spec. You can do a normal 612 class, you can see the type of dBs that you're going to cater to, versus the gray line where you have a combination. So a lot of engineering goes into it. So roadside have a different section, rail side will have a different section. It is not that one section can fit across and give the solutions. This comes back to the original problem. Like we said, we were designing for somebody who could take it as one single building, or there could be multiple clients. So this is how we're trying to do a central area. This is a common area for everybody, and it is not a tenanted space per se. And in the evening, we expect people to walk across, go and use these spaces. So how the building is designed to cater to that requirement. So that's the core. The central area is a common area where even if it's divided into 4 offices, any of those offices can cater to that requirement and go about doing it. The roof overhang is not only architectural, it was also to cater to a solar requirement. So the facade took care of the energy goals that we wanted to cater to. Another project that I'm running across because I'm already half time, so I'm just trying to skip through slides a little faster. This is something else that we are doing for an end customer in this case. In this case, we're doing it for Capgemini in SIPCOT in Chennai. What are the problems that we're trying to save over here? Energy saving, yes. Structural efficiency and material contrast. We wanted to do a building which is very different and very contextual. From a context point of view, you have all these campuses all around the proposed site. This is the problem statement that we got, where there were 2 buildings, existing building on the left, and there was a certain amount of population that we were wanting to cater to. A very simple section. The lower level was more public because we wanted people to move around the campus, experience the campus. Workspace were taken at the upper level. So that's the campus that is planned for. As of now, the right side 2 buildings are what is getting built as of now at site. They had an existing campus, so there were this bus parking because this is located a little far away from the city. So people are going to come by mass transport and they need to walk across the distance. So we did all our energy mapping, and we realized that we want to make the building still something that where people can walk around. This is the network that people are expected to take, not that you can choreograph somebody's walk path, but this is something that we want to do. The central space was left completely open, and we designed something we call as pods. Pods are nothing but taking some of the functions which need not be within the office building and creating them as separate bespoke spaces, something like a candidate experience. What is a candidate experience? Somebody who's trying to come to Capgemini and wants to be a part of that organization. Where does he give the interview? Does he have to walk into a shady small meeting room where he doesn't understand the ethos of Capgemini as a campus? Or can his first experience be such that he remembers it and he has all the other experiential notions? So then we decided that yes, we need to get these pods going to ensure that that first day, first hour experience is also created. So we call it as a campus walk. That's the section that we went about doing. This is an overall section. So the smaller ones are the pods. So they are more human. When you move around, you understand the scale, you relate with the scale. And then there's a mass that we are playing around with so that none of the buildings are the same size, not the same blocks. From a workspace strategy, we wanted to connect buildings, make people walk across because it is eventually for a campus, for an organization. So those bridges that you say are the one which is connecting. Kept the building very simple. There are only 2 sections in this building. One, the left one, where you see shading devices coming out, light shells put across, vertical fins put across to cater to the heat requirement that Chennai obviously faces. At the same time, we didn't want that to be a deterrent, that people cannot step out. People cannot enjoy balconies. People cannot enjoy workspaces. And hence the second section, which came across as a facade, which is more like this. The fins here are not geometric purely from a point of view of geometrical arrangement, but a heat mapping was done to the extent that we could do for Chennai, and based on the heat mapping, we have decided what should be the density of the fins that we are trying to put across. These are aluminum fins. We wanted the building to look a little more humble, so we went about doing certain softer elements like a wooden oak. In terms of the finishing that we are putting across, the lower level also had similar finishing. And the greens that you see are the green terraces, which will be accessible for everybody from the workspace, also from a fact that air quality is more controlled. We had 2 floors of parking facade, wanted to make sure we end up doing something different. So we're trying to put across a different materiality. When I say different materiality, it's not something that is not done, but it takes a lot of effort today to get these slabs done and built at site and really get executed. Those spots are going to have shingles, more from a point that people feel this when they look down into the campus, that this is more homely and not just something which is very rigid. The pathways. So this is where we started with, that this could be the box, but we realized that the box is not giving justice to the plan that we have put across. And hence we said that we'll sculpt the building a bit. And this is finally what we are trying to do to ensure that they are not rigid, they talk to each other, and the form that we have formed at the lower level somehow translates back into the geometry upwards. And that's the experience center that they are going to have as they come into the campus. A small walkthrough to explain the shaded spaces that we showed you in the plan. These are the parts of how the build spaces transition. So this shot is as if you are in the bus parking, you have come out, and this is the series of steps that you can take and walk across at upper level to connect, or you can walk below them so that you are walking through shaded spaces. And these spots you can get connected at the first floor also, not only in the ground floor. So the idea is people still walk across. People may not take the upper level at probably 2 o'clock, but they can take it at the evenings, and at the 2 o'clock they take the lower level, which are shaded spaces, to use all these functions which are very activity driven and becomes the heart and soul of the campus, to which everybody tries to come out to. This is the overall vision. The one towards the roadside, the 2 buildings are one which is getting done as we talk. A third building that we're trying to show you across is something that we're doing in Bangalore. When I just walked in, I was hearing about computational design and how far we are from that. But we are trying to do something where we use BIM as a technology, at the same time not make it complicated and still look at mass customization, which means a complicated design need not be complicated from an execution point of view. So the typical approach of atrium would be that you have 2 blocks and the atrium is very straightforward. What we end up doing is just what we really do to twist. When we twist arm. So that is all that we did. And this was done purely because the client was not sure whether they're going to build in one go or they could build in 2 different time periods also. So we said regardless, the building could connect, and the flow plates are designed obviously to cater to that. This is a wireframe extract from the geometry that we ended up doing. So to a certain portion, it is still a straight facade. It connects the 2 blocks. So the geometry becomes very, very important over here. And at the top, it is again simple. So that's a geometry that we are trying to put across from a facade engineering point of view. Again, the inspiration also came from a little bit of what goes into the aerodynamics and why is it serving the way it is serving. So the rest of the building is very simple, horizontal facade, but it is just the central area which becomes the USP. And the idea is that typically the experience is set only at the lower level. We wanted to make sure that the experience is not just at the lower level, but goes around vertically. Hence the twist, and hence the idea of curving it all the way till the top. And so the workspace which are going to enjoy the spaces inside are also going to benefit from the language that is created on the exterior. Some extrapolated sections to show how these things are going to come out. Finally, something that we are doing in Bangalore. This was a very engineering challenge for us, purely because structure was the one which decided what the facade will going to look like. So how structure can become very integral part of what you go about doing. So this is the auditorium which we finished in Bangalore. The lower level, this is the form that we have finally built. The lower level is obviously more rigid because it has to cater to the requirement of the auditorium, and it had a training center. So the right side is more of the training center, left side is more of the auditorium. And being a public building, it gives you the flexibility to play with the form. And this was done for a government organization, so they wanted it to be pompous, yet within the budget that they have. So we said, what do we do? So this is the framework that we did. This framework is done completely in terms of this section. These sections are cut through different places, which will make you realize that one section is not suitable for everything. There is a different section which is cutting across, and to get that form, what do you do? A small video to explain exactly, sorry, go back. Just give me a minute, please. Somehow that it's not playing, I'll skip that. So this is trying to show how a green section, which is 20.65 at the lower level and 35 at the higher level, goes to 42 at the lower level to 50 at a higher level. And then it goes from 46 to 50. And again, a different one. So here, the topic that we started saying, precision in design. This is every member of this section is different. No two members are same, purely because the section is continuously changing as we go around. And that's the wireframe model which was done with the metal engineers, with the facade engineers, to ensure that this framework, when it is built, it is good to cater to the material that is going to be used to finally envelop the whole thing. And that's the type of engineering we come across to ensure that each and every component is taken care. So one is a top shot. That's a very simplified form to explain what could be done even in this, because our government project had challenges in how a simple thing like a metal member could come across and take that shape. So that was the actual shape that we desired, and that is the finished product in terms of what was done. But here, what became very important again, that the problem was solved more at the engineering level, at the desk, than trying to solve the problem at the site. Yep, that's where we are. Some takeaways which we felt are important to cater to today's idea. Thank you.
Thank you so much, sir, for a fantastic presentation. Amazing solutions combining both design and engineering. I see the Chennai Promenade building a lot when I cross the airport, and I'm really excited to see it done. Yeah. So let's invite our last speaker before we take a break. Please welcome Mr. Rohan Keswani from Aluplex. Please come, sir.
Where's the, yeah. So good afternoon, ladies and gentlemen. First session of the afternoon. And I think all of you guys are all waiting to go and have your coffee. But I'll make a quick presentation for all of you. So I'm going to talk today about scaling smart skins, which is facade innovation across commercial projects and IT campuses. So before I start, a little bit about Aluplex. Aluplex has been around for more than 45 years now. We've done more than 500 projects in the IT space, in the commercial space, in high-end residentials all across the country. And you know, we've been around for a long time. When it comes to Chennai, the first, our history with Chennai goes back more than 30 years ago, 1996, when, the India's first unitized glazing project commenced in Chennai. At the time, this was the Oberoi project, and we started this project. And since then, there was a change in ownership. It became the Hyatt later. But for this project, we actually developed this unitized curtain wall system along with a company in Australia, imported all the glass from Singapore. Technology was at a very, very nascent stage at that time. And since then, Chennai has come a long way. Besides that, we also worked on the Tamil Nadu Legislative Assembly as it was at the time. Now it's the super specialty hospital. Used very, very different elements over here. We used anodized sheets, perforated sheets, and a lot of other complex elements on this project. We've also worked with Capital Land, worked on the ITPL campus over here in Chennai, where we worked with Ascendas and did this particular project over there. This was done about 10 years ago. The Taj GVK, which is now called the Taj Clubhouse on Mount Road in Chennai as well. And this particular project is the Ramanujan IT City. This was a particular campus that we did. It's a very, very large campus. And, the original concept of the architect over here was to have very, very wide glass panels. So keeping that in mind, they had developed a system which was a semi-unitized system where you come from the outside and you have these each, mullions on the outside, etc. We converted it to a unitized system. So we converted this whole thing to a unitized system, but that would mean having very, very, very large panels. So what ended up happening is we ended up having a unitized panel, as you can see, which was 3.9 meters wide by 4.2 meters in height, because they wanted a particular panelized system where you can see the lines of the divisions of the cladding was not aligned with the divisions of the glass, point number one. And point number two, you ended up having a 3.4 meter wide vision panel, fixed panel, and then next to that was an 800 mm width operable panel. So you had these huge panels that we had to develop, we engineered, we tested, and had to supply them to the site. It was quite a logistical challenge. This is from a factory, the panels getting dispatched. We had to, each panel was 16 square meters in area. Typically a panel is 5 square meters, 6 square meters. But we took on the challenge and we developed a system, we engineered it, and we supplied these huge panels to the site from a factory in Hyderabad to the project site. This is how the building looks. I think people will see it when they, around in Chennai. You can see these large panels, 3.4 meters in width. The other very important element of this particular project is that we had a glass box, a double-skinned glass box, which is cantilevering out from the facade. As you can see is that, we had, it lights up in the night and looks very nice, but the point was that it is cantilevering it out on the top of a 13-floor building, and actually executing this was quite a challenge itself. This is how the whole different, if you opened up the elevation over here, as you can see, the section, I'll get into the section later. So this is the plan. So there is, on the inside is one particular glazing level, which is right at the edge of the floor slab. Then we have a particular catwalk. And on the outside of that, we have a secondary skin on the outside, which is a continuous skin, which is a bolted glazing assembly to get that transparency and that feeling that they required over there. So you ended up having a system which looks like this in section, where you had the primary facade barrier, which was at the edge of the slab. And then you had a particular catwalk. And in front of the catwalk, you had a continuous bolted glazing assembly, which had to be, you had this, it was cantilevering it out, as I said, about 800 millimeters, about 1 meter from the edge of the slab, and executing that, making sure you have the access equipment, making sure you could lift those large glasses and putting that in place was a challenge in itself. Moreover, we had issues in the civil tolerance. There was more than 100 millimeters in and out tolerance in the edge of the slab. So the brackets had to be accordingly modified, adjusted. Took a lot of effort, but we saw that through as well. That's how the glass box looks right now, and I think people have seen that. The other project I'm going to talk about in terms of new age commercial campuses, as I said, is a particular project which is the Platina building in Mumbai. Very interesting project. Besides having curved glass in the project, we used a particular sun shading system that we had developed for this. So we indigenously designed this system. As you can see, is this particular sun shading system has an actuator which is then connected with a particular mechanism to the louvers that allows this mechanism to pivot and is controlled to the building management system and the building control system. So that based on the angle of inclination of the sun, accordingly we are able to adjust the angle of incidence of the particular sun shading aerofoil louvers, allowing for temperature control and shading in the building. The next project I'm going to talk about is another project that we did for Godrej Properties, which is the headquarters of the Godrej Group right now, which is in Mumbai. Very, very interesting project. A lot of elements. Worked very closely with Pelli Clark Pelli Architects in New York, along with ALT Cladding in Manila. And very interesting project. They have did various different elements. So the idea is that today's commercial campuses, you don't want just a typical glass box building. You want different elements, different materials. And that's what we were able to do here, because we have a system where there was stone cladding on the outside. So you have a continuous unitized facade, but you had 1.2 meter wide sunshades that were cantilevering from the unitized curtain wall mullions that were engineered accordingly. In the internal part of the building, we have an atrium where in the spandrel panels, we didn't use glass, we didn't use stone, but we used a wood-finished wooden slats that were incorporated into the atrium. And then you have a large atrium wall with stainless steel fittings and tensegrity structure as well. So this is how the sunshade was designed on the external envelope of the building. As you can see is that we engineered the mullions such that they were able to withstand the heavy stone sunshades on the external side of the building. That's a 1 meter cantilever. Each panel was 1.5 meter in width, and that was quite a challenge to execute that. This is how the building looks. You can see the stone sunshades on the outside. Those stones are not penetrating through the barrier of the mullions to go, and so that would create leakage issues. So we obviously engineer the mullions so that the bracketry system is not puncturing the facade, the weather barrier of the system. This is the other element that we designed. This is coming into the internal atrium of the building. It was also a unitized curtain wall system on the internal atrium. Over here in the spandrel panels, because it was an atrium, we worked in order to reduce the noise that would echo in the atrium. So we had to particularly design the spandrel panel with wooden slats and the sound absorbing panel to reduce we had a particular noise reduction coefficient, the NRC, in order to reduce the echoes, and the perforations were made accordingly in those panels accordingly as well. So it's a very nice kind of finish that you have on the inside, which is not that complete glass look, but has these elements of wood on the inside. This is how the atrium finally looks, and you have these nice elements over there. The other project I'll talk about, again, using a different element, is using a lot of stone on the outside. Typically, you have drywall cladding, dead wall cladding in the external element of a side of a building. But in this particular project, we wanted the construction of the facade to go along with the structure of the building, including the stone cladding. And the architects did not want an all-glass building. So we had these alternating stone and glass elements. And we did this all in a unitized curtain wall system. So we specifically designed a unitized curtain wall system that could either incorporate stone in the infill panel or could incorporate glass into the infill panel. So the entire stone panel was accordingly, assembled in our factory within the unitized curtain wall panel, allowing for fast construction, easy logistics, no requirement of any scaffolding in terms of normally what a drywall cladding would involve. And eventually we were able to deliver this particular element where you have either an all glass panel, a combination of stone and glass, or a fully stone panel, giving you this particular look. The last project I'd like to talk about is this project which is currently we're working on in Hyderabad in Kokapet, is a project called My Home Grava. In this particular project, we have various elements. As you can see, different sun shading elements. You have on one particular elevation, you have a lot of aerofoil deep 500 millimeter sunshades. In certain locations, you have vertical L-shaped fins. In certain locations, you have different louvered panels. So we developed this particular system, keeping in mind how this unitized curtain wall system could incorporate horizontal fins, how it could incorporate vertical fins, box fins, how it could incorporate U-shaped fins, all within the same unitized curtain wall system. And the way we were able to do that was by being able to devise a particular bracketry system within our mullion that would allow the sunshades location to slide. So as you can see, is we have this particular right over here, you have this particular bracket that can slide up and down without actually having to puncture the mullion. So you could adjust the position of the sunshade, so you have no issues in alignment and a very crisp look to the building. I'll just quickly show you how that particular assembly comes to place, how that installation of the entire assembly comes to place. This is how I'll just wait for it. So this is the edge of the slab. You have a bracket which is installed at the edge of the slab with anchors. There are slots within those anchors and washers to allow for tolerance, serrated washers to allow for tolerance of the bracket to move in and out. The panels are assembled in the factory. There are hook brackets on the back of the particular bracket. And as you can see is then you will have these particular sunshade brackets which are fixed onto the panel. These horizontal sunshades can then go on to the particular panel, and the panel is dropped into position at site. Now, based on in order to level the bracket accordingly, we have leveling bolts which allow the panels to move up and down. There are various other types of curtain wall systems that we have used in that. As I said, one is with a horizontal fin, one is with the vertical fin, one is the U-shaped fin, and we're able to use that accordingly. So here, as you can see, is a combination of a vertical fin along with a horizontal sunshade as well. So on one side, you have a particular bracketry system that you can slide up and down to match the position of the horizontal sunshades, and that can come together with your vertical fin. So this is how the elements came together, and this is how we are able to achieve these different geometries to create this element of sunshading on the building. This is a U-shaped fin and how that comes together. So this is the project. We've almost completed the project. This is a picture of about a month ago. And I think today, right now, the handing over process has started. You can see how those particular different sunshades on one particular elevation, you have U-shaped fins, one particular elevation, you have vertical fins, and you have horizontal sunshades on some parts of the building as well. As you can see over here is what we did in this particular project being different is that we developed all the drawings on Revit. All the shop drawings, first we got a model from the architect in LOD 200, and we then developed it further and we took it to LOD 400. And we were able to then, this is how the model came to us first. We took it further, we developed it. Every single family of elements was accordingly labeled and added to the families. We were able to then, every glass size, every glass panel number, every element was numbered. So then after that, we imported this entire Revit model into Inventor. Inventor is what is used in order to create our fabrication drawings and our assembly drawings. So straight off that model, we were able to, without actually doing any manual intervention, we were able to get the glass sizes, we were able to get the fabrication drawings, we were able to get the cutting sizes directly fed into our CNC machinery in a factory, and we're able to produce these particular panels. So using that entire ecosystem, we were able to achieve this. So we've come a long way, is what I like to say. 1996, first unitized project in Chennai is what we did. 2026, we've delivered a project like My Home Grava, where, 1996, we did not use any computers at all. We were using hand drafting, all engineering calculations were hand done. Today, we are in 2026, where we're not using any AutoCAD, but doing everything in Revit. We're doing everything in Inventor, and we're able to deliver these various kinds of different projects. Thank you very much, ladies and gentlemen.
Thank you, sir. Thank you so much, Mr. Rohan. A fantastic body of work across India, and especially in Chennai, all of the buildings are landmark buildings, and everyone, passes them quite often. So thank you so much for that. Thank you, ladies and gentlemen. We will now have a networking break. Please do visit the sponsor booths. This is a great opportunity to obtain information from all these companies that we've seen so far. May I request all the speakers of this session to stay back for mementos and a photo opportunity. I also request Mr. Pratik Doshi from Shuko to give away the mementos. Ms. Nasira. Welcome back, ladies and gentlemen. I hope you had a nice coffee break and a very fruitful networking session. We still have quite a few sessions to cover for the rest of the day. And let's now welcome our next speaker, Mr. Nandakumar BS from Evermark Façades. Please come, sir.
Good afternoon, everyone. I hope you can hear me. Yeah, welcome back after a short break. My name is Nandakumar. I am a facade consultant. We are based out of Bangalore. And my topic for today is on the cost. So value engineering is my topic today. So I hope I can keep you interested in on this topic because it talks about cost. So I'll just go through the brief about my topic today. So when we are appointed as a consultant for a specific project, so we get the intent from the architects. So we start working on the designs, basically the design basis reports. So the initial brief will be there's no compromise on the architect's intent, and we give the best possible technical solutions to the client. And after the design brief report, so we give the budgets to the client, and that's when the client calls for a value engineering meeting. So the value engineering meeting happens like this. So we have an intent. So first thing is we don't compromise on the intent. Neither the client wants to do, nor we want to do it. But the cost has to be reduced. That will be the goal for this meeting. So this is just a small humor just to start the presentation. But I'll just get into the more detailing and a systematic way of doing a proper value engineering especially for the facade projects. And I'll take you through a couple of case studies how we have done this, because value engineering is part of our work, so we can't escape this. And the definition of value engineering is you will have to reduce the cost, but not at the cost of the functioning of the material itself. So the definition is it's a systematic way of arriving at a cost with the proper life cycle. So you will have to get into a life cycle costing of the material along with the basic cost, installation cost, your performance, everything you will have to consider and do it. So it is defined as the value is defined as the best possible function with the lowest cost. So function divided by cost is the definition. I'll directly get into a project. So this is a project we have executed in Hyderabad. I'll not get into the whole project value engineering. I'll just take a small portion of this. So you can see this portion. This is actually a ground plus 22 floor building, wherein I'll be talking about the area where we have this parking. So this parking lot is from the 2nd floor to the 5th floor. It's about 3 floors. And the architect intent is to have a box louvers kind of a fins, which is about 100 mm by 150 mm at 200 mm, 250 mm spacing. So this was the intent, and there need to be given some steel stiffeners and some steel backup structures also for some areas. So with all that, we arrived at a cost of about 12,500 rupees per square meter. Then the client called us and told us for the parking lot, we don't want to spend as much as this cost, which is equal to the facade cost itself. So the overall spend of this area alone was coming to about 6 crores. So then we gave them other options. One of the option was this, which is normally done in the Western countries for the parking. So which is combined with other shopping and other things. So we gave these options, and we were able to reduce a little bit of cost with the GI, pre-coated GI sheet options for this with some kind of patterns. But the issue was this was not allowing the light to come into the parking, and there were issues with the lead, and it was obviously changing the intent of the architect as well. So this was not accepted by by any of us. Then we gave the option of, so we went to a lowest cost option of wood, plastic, composite panels. So which you can see here. And we tried working on that, and that gave us a very good cost reduction. But looking at the building and the facade, this was looking as if it is a very cheap product on the building. So doing a fantastic facade on the office areas, and when suddenly somebody looks down, it looks as a very cheap material and a compromise solution. Then we went with the similar with the other option kind. It's called as a Swiss panel, which is it's a metal with powder coating with special kind of coatings and all that, but that was also costing higher. Though the client liked this, it was costing more than the allowable budget. Then we gave the option of the perforated sheets with the powder coated perforated sheet, and we told the client that you can have different patterns in this. So the cost was coming more. Then we gave them an idea of reducing the area of the sheets. Maybe you can make it as an alternate panel so that your almost 50% of the area can be reduced. So with that, we worked on the drawings and all that, and we gave. The issue was that we have a parapet wall for the safety requirement for the car parks. So that was getting highlighted where the panels are not there. So aesthetically, the architect was not happy with this kind of a situation. So this was also rejected after a lot of workings. Then we thought about this kind of sheet. So the original intent was 100 by 150 mm box. So this was look and feel wise, it was looking same because the width was 100, the depth we reduced it to 35 mm. And we gave them an option with aluminum and galvanized, the galvanized powder coated fins kind of thing. This is something like a C-type fins. So in principle, this was agreed by the client and the architect. Then we made some mock-ups. So we want whether to put it vertically or horizontally, what should be the spacing, what should be the color. So we made some mock-ups like this and shown to the, and this is the color option, this is the vertical option, and some spacings also we have adjusted and we showed it to the client, and this was accepted. And this is the finished product. This is the completed building. This is the intent of the architect. So we were able to reduce almost 55% of the original cost. So this was an exercise which we did on this project, where there was a significant reduction in the cost as well. Also, there is no compromise on the aesthetics. And the original intent of the function versus the cost was achieved on this project. So I'll just take you to one more case study before we get into the details of the value engineering process. So this is a building in Europe. A client came to us and told us that we need a building exactly like this. And unfortunately, the client has already built the structure and they didn't have an elevation for that building. The only thing we had was few drawings like this. So then actually the client did not have an idea of what a facade consultant role is or an architect role is, nothing. Then initially we thought of walking away from this project because the architect is not our core area. Then the client insisted that you can appoint your own architect and you can get this, but we need a building looking like this. This is what the brief which was given to us. So then we went to the site, we did the site survey ourselves, we took the measurements, everything, we started developing the drawings, and we started putting across in the way in which the building is actually done. So the thing was, the original intent was a vertical building which the client has seen somewhere in Europe, and our building was a linear building. So this building was coming up in Bangalore. So we developed this, we hired an architect, a professional architect, and we developed this intent and we showed it to the client, and with a lot of options we did, and this was the finalized one. Then we started working on this. So the major thing was we have to achieve this fins. So you can see there is a taper here, and as it goes in between it is bulging out and again it is tapering. So every 2 floors this is changing. So then we thought of what material we should be using on this. So first we tried with GFRC, which was okay, but it was very heavy on the building and a lot of engineering has to be done, and maintenance wise we thought it is not a good material to choose with. Then we've thought of HPL fins. Personally, as a facade consultant, we don't want to put HPLs on the elevation of the building, which is, it can be done for interiors or for the entrance areas and all that. But on the building, we were also having little bit of reservations, but we tried this option. So this was also not very convincing. Then we worked with aluminum again. We came back to aluminum. We started doing the, of course, you can do the powder coating or PVDF, the color we can do. So we started with solid aluminum sheet, considering the fire requirements and all that in mind. And the challenge we were facing is to have this kind of a detailing. So to bend this to this shape, doing this with solid aluminum sheet was very difficult because it's a solid sheet. Then we ended up doing with ACP sheet. Of course, FR grade ACP sheet, we started working on that, and we did some small tests and the mock-ups at the factory, and we started working on this. We were not able to reduce much of the cost in this, but somewhere in between, we like the cost was varying between 1.5 CR to about 2.5 CR. So this was coming up to about close to 2 CR, and this option we finalized by doing some mock-ups and all that, and we started working on the engineering part. So the challenge was to get the 3-dimensional shape, and every joint was having there are 4 joints coming and joining, and one area it's bulging out, one area it is tapering inside. So we had to develop different brackets. So what we did was we standardized the bracket and made it like an articulated bracket we designed. And this was the spacing from the glass to the fin. It was about 450 mm, 200 mm, 250 mm gap, and 200 mm was the fin. So we did all this exercise, and we did the engineering part of it. We checked the structural calculations and all that. Then for the fixing, we have to develop this MS structure. So we did on this for this, and we cladded with this in that shape, and finally we were able to achieve this this product. So this is the finished building, which is currently completed in Bangalore, and the client was very happy about the output of the project. And now the client is considering the same design to be executed for his project in Hyderabad. So we are currently working on this. So the same design will be executed there is what the client has given us a brief. So we have started working on this. So coming into the phases of value engineering and the methodology, how we need to achieve this is, there are different phases in this. So first is the information phase. So the information phase is the most important phase, wherein first we need to understand what type of project we are working on, whether it is a commercial building, hotel, residential, or it's an institution building, etc. First is we have to understand that, because the material selection will vary for different projects, and different functions will be there. For example, for a hotel, the major function may be an acoustic. For the commercial building, it may be a good performance glass, etc. So we need to, so in the information phase, we need to get the data based on the functions, and then we need to identify the cost, define requirements and identify the cost. And we need to also think about the risk and constraints. So somebody would have already used this product in some other buildings. We may have to get some feedback on that. So these are all collecting the information in the first thing. So there is a technique called FAST diagram which we can use for this. So it's a very simple thing. Just put it in a, we have to put it in a like a flow chart thing, and we have to do it. So it's like you will have to ask questions like how, why, and when, and all that. So how is from you can do something like this. So for example, if you want to select a cladding for a dead wall, I am just giving a basic example. So there may be many options for you, like you can go with an ACP cladding, or a solid aluminum sheet, or the clay tiles, or fiber cement boards, stone cladding. So you have various options. So you will have to first identify all these basic options. Then you get a basic price for the materials. Then you will have to understand the installation methodologies, and also the functional aspect and maintenance aspects. Because sometimes the initial cost of the material may be less, but when it comes to maintenance, it may be very high. So that is the functional aspect which you have to consider. Then you will have to do the performance, of course, without any compromise on the aesthetics. So we will have to do that, and we have to find out the best cost for the function for the value engineering. So coming into the function analysis stage, so you will have to first define what is the purpose of using this material on the building. So first is the aesthetic architectural intent. Then it provides an insulation for the structure and for resisting the weather. Of course, the fire ratings and other things from the compliance perspective. Then you will have to divide it into basic functions and secondary functions. So I am getting into more depth of the value engineering instead of directly telling that this is a cheaper material, just go with that. So this is the basic function and secondary function, and then you can use the techniques of fast diagrams, and you can arrive at the best material for your project. You can also think about this methodology of which item is, if you are going for an entire BOQ of the items. So maybe the one item may be costing the maximum amount in a project. Like for example, in a commercial building, your unitized facade may be the major item. Like 80% of the cost may be your unitized facade. So you will have to target that for the value engineering instead of targeting small items. And maybe the alternatives for how instead of unitized facade in some areas whether you can change it to some other way of installation. All that you can do it with this help of this option. Then the other way is thinking out of the box. So this is something which we would have been working on the facade from last many years, and our mindset would have been limited to few elements. So think out of the box. So nowadays you can think of some like just doing a dead wall with greenery, something like that, so that you can, of course, the life cycle cost also you will have to check. So likewise, you can think of different options without compromising on the aesthetics, and something like new materials, some materials. So we have done projects with the normal wire cut bricks also with wet fixing in some areas. So there is a technique to do that. So we can think of those kind of things. And the most important thing is implementation of this. So once we have the major thing is coordination between the architect, facade consultant, execution parties, clients, everything, PMCs and all that. So the PMC comes to the role in this stage, wherein they will have to define clearly what is the timeline for this, resources for this, and also who takes the responsibility of implementing all this. So we can do mock-ups. So as I showed in our pilot, our projects earlier. So we do, so every project we do a mock-up, we take every stakeholder's buy-in, then we go for a mass production. Because once in a mock-up, you will come to know about what are the constraints and risks and uncertainties, installation issues and all that. Then of course, continuous monitoring is required once the installation is done. So you will have to see whether the intent is of choosing this is working. Get the feedbacks from the site level engineers and try to improve upon the shortcomings. Then the documentation is important so that this can be used for your future projects as well. And the last slide is about the overall process summary I have just given here. So in value engineering, first thing is identifying the opportunity where the value engineering is which needed. That the client will tell you, because they will obviously need a cost reduction in your proposals. Then gather data. We can use fast diagrams, as I explained. Functional analysis is required. Then you can explore alternatives with the help of the different materials you can think of. Then we can develop recommendations such as the functions and cost targets we can keep, and you can work as a backward integration. Then implementation and following up and review, wherein we will have to engage ourselves with the project management consultants, clients, the site, the contractors, of course, and we will have to do the best possible value engineering considering the cost and the maintenance of the product. Thank you very much.
Thank you, Mr. Nandakumar, for sharing your value engineering process. It's very relevant for a cost-sensitive market such as India. Next on stage, please welcome Mr. Harsha Raj Shetty from Shuko.
Yeah, good afternoon, everyone. So let's begin today's presentation. So today I am presenting on innovative facade solutions that Shuko as a system supplier is providing to the industry, right? To start with, to set the context of what I want to showcase today is, let's imagine you are entering a world-class luxury hotel. So what is the first experience that you see? You're not entered the lobby, you're not seen the hospitality there. It's basically the building. It's the building envelope that encashes into your mind, right? This is very good. The first impression of how well the hotel and how well the hospitality is being developed, right? So just one second. Yeah. So the opinion that is formed by looking at just the building envelope creates a certain luxury, high-end, premium kind of intention towards the building. So with this, today's presentation, what I'll be presenting will be more towards how the hospitality industry is shaping the construction, and in particular the facade industry. So there is a huge demand growth where there is a continuous growth of 9 to 12% within the hospitality industry. This is a post-pandemic improvisation in the industry, where there is an increase of demand for domestic leisures, events, weddings, and premium rooms. This has also expanded into tier 2, 3 markets, where there are mixed-use projects, where there are hotels and convention centers, and there are probably office spaces also. And there is luxury and wellness, and probably destination buildings as well. What has also come up is the rise in the facade specs that goes into these hotel buildings. So there is an increased demand for iconic architecture. Like hotels are more of an emotional property rather than just a functional one, like our office spaces and so on, where the architecture, the developer, they are keenly interested and invested in developing it as an iconic structure, right? Along with that, there is a requirement for performance. There is a requirement for having a secure and safe building, where the people who are going to stay in the hotel are having a comfort factor in it. And that, along with that, comes with the demand for a wholesome envelope or a wholesome building envelope solution, where there is an integration of multiple systems. It's not just facade, glazing, it can be doors, sliding windows, openables, so many more. And with the sustainability topic all around the globe, there are hotel groups, there are international hotel groups which are keenly looking at developing circular materials, being more sustainable in their offering to this industry. So what does this bring into the facade? So as an effect, the facade has just moved from an aesthetic finish to a more strategic high performance package. So when we say high performance package, it involves a lot of engineering, it involves a lot of tested systems, not just to meet the architect's intent visually. So what this brings further is, with the growth, with the increase in hotel and hospitality buildings coming up in India, there is a sustained facade pipeline. There are more hotels, more upgrades happening. There are even renovations happening as well. And there is a performance-led specifications, which is very keen when system suppliers like us are in the working. And there are solutions where there is integrated with design, engineering, and ease of installation also. So this kind of gives a competitive edge to whoever is working on the project, may it be the architect, the developer, the consultant, or the vendors, the system suppliers that are involved in the project. So with this, what I want to keenly present is how is Shuko approaching this as an opportunity, right? So what majorly we see is 4 different aspects. One is the bespoke engineering. So with bespoke engineering, we are able to address any kind of intent, any kind of performance parameters, any high-level testing that is required, that can be done through bespoke engineering, followed by integration. With the help of integration, and the topic itself helps us to involve most of the systems and provide a wholesome solution, so that the client, the stakeholder, doesn't need to run to too many people to get his entire building done, right? Then comes safety, which has been a very integral part of what Schuko does as a system supplier, and it also implies to hospitality industry, where there are openables, there are sliders, which I'll be probably taking up further down the slides. And then, as I said, the sustainability part, where Schuko has been keenly interested, and Schuko India itself has invested a lot in bringing this sustainable part to this industry as well. To start with, I'll first have a quick case look at bespoke engineering, what we have actually been successful in doing yet. So the first, for the case study, I would start to take about the project of Taj Lucknow. So Taj Lucknow is a premium hotel project based in Lucknow, which is around roughly 2,000 square meter and has 2 towers. So it's around 38 meter tall, 3.5 meter floor height. More or less, it is a very simple project, but the complexity is when the design comes in and when there is architect equipment. So the entire facade is an undulated angular facade. So it pretty much moves like a wave on the outer envelope. And the overall wind load is around 2.2 kPa, and the water tightness required here was pretty high comparatively, which is around 1000 pascals, which is not so usual as of now. And all with this, the entire facade has to undergo a seismic cracking of around plus or minus 15 mm. This has to be not just to be a design intent, this had to be proved with the long list of around 14 testing parameters, which had to be concluded through a third-party testing as well. So all this had a certain intent of preserving the architect intent along with providing a high-performance system as well. So at Schuko, how do we take this up? So with the challenge we had, there was a distinctive facade, wave facade geometry, which had multiple angles of 161 degree, 167 degree, and then again 175 degree. So this gives a dynamic architectural expression to it. Along with it, there was a requirement for an open groove system which maintains the equal consistency of the facade, followed by the seismic horizontal requirement, and a openable system also, which can be concealed completely in the facade. So this was more of the facade challenge. So going on to the next was, how do we approach the multiple facade angles? So this complete facade was developed based on our stick frame construction, SFC 85, where the angles were designed based on custom mullions and retention profiles for different angles, which will basically align with the angles as mentioned in the intent. This combined with our subframe system of AWS 58NI gives a very concealed window system along with the facade. So this was how the angles were accommodated in the design. So going further, what was the challenge with the performance? So the intent was clear. The testing requirement or the performance mockup had to undergo around 14 tests as a part of their PMU test. And this was basically to understand how it will perform in the real-time, real-world scenario. Is it structurally stable? Can the design which is unique, can it sustain weather tightness? And this all was part of the design requirements. So how do we understand? So one of the biggest challenges was how do we understand the seismic performance, especially with the custom design profiles. So we had developed a new bracket which actually aligns with the different mullion angles. Along with that, we had also introduced a 3-barrier system, which equips us to have the 1000 Pascal water tightness proved with this particular design. So as we see, we have like multiple barriers, 1, 2, and 3 as highlighted here. So with this, we had gone through this testing because this is already an ongoing project. So this entire system was successfully tested, and all the 14 parameters were also successfully completed as well. So yeah, basically this was the render and what we had received, and this is what is, I think it's almost done. Probably this is a bit old image, but this is what we are actually looking at as the exact project. Right? So this was most of on the bespoke engineering. So today on the integration part, I want to bring in something new, something interesting that Shuko has introduced. So this is what we are looking at currently. So there is a huge requirement for entrance facades which are large, transom-less, no blockage of vision lines. There is a requirement for open sight lines, maximum light, and still make it iconic. So what do we do? So we started off with the simple design, make a transom-less facade, keep it simple, make it look minimal, and then with that, with this concept genesis and so on, we have what we present to you is Shuko Facade Wall System 85. So this particular transom-less facade can go up to a 9-meter triple height facade. It is completely a prefabricated assembly where the mullion, bracket, glass supports, everything is by Shuko. There is a dual glazing option of structural glazing and capped. And then there is we have the terminations which can go with the wall, the floor, and the jam sides. And this is completely a design and built by Shuko. So when there is someone that is asking for FWS 85, everything will be under the scope of Shuko, giving you a better quality and engineering aspect. So as I said, this is a conventional facade which we do as FWS 50 NI. So this can be provided as a new with transom-less facade with FWS 85.NI as a cap system. Likewise, we have the conventional structurally glazed system, which again can be shown up as a transom-less facade system with FWS 85 SG-NI. So this is again what we want to show as a benefit is how it is better. So with terms of investor, there is a reduced time of fabrication and installation because everything is pretty much fabricated by Shuko and it is supplied to site, right, straight for the installation. There is an inclusion of brackets. There are more clear aesthetics, and the weather tightness is also better because we have already tested the system for up to 1000 pascals of water tightness. So this gives you a better ROI. There is a reduced project risk because the quality basically depends on Shuko as a system supplier, and there is a lower life cycle cost also. In terms of architect aspects, there is open sight lines because you can go up to 9 meters without any blockages, horizontal blockages. There are clean interfaces, and there is a flexible integration where we can include doors, probably windows down the line. With doors is something that we are already providing as well. And when it comes to fabricator, since it's a prefab assembly, the fabricator has to be more involved in getting it installed, and the installation also will be easier because the brackets and everything will be from Shuko, right? So, and yeah, single source support because Shuko is designing and building everything, the fabricator can get in touch with Shuko to have any support or technical expertise required for this. So these are the tested parameters for the FWS 85. So we had a target of going to 1.6 kPa and we have still gone up to 2 kPa with this. And we have done a 1000 Pascal water tightness again with this particular system. So that was more about entrance glazing, which is a new introduction from Shuko India. So I quickly jump into safety part. So safety, as I said, has been a very important requirement for Shuko as a whole. So in a real world scenario, in high-rise buildings, there is a lot of dynamic wind, which can create a problem with your openables where they can probably break out from their friction hinges and fall out, right? So how do we address this? Because this is something that is happening. It is not that theoretically that this is happening and we have to control this. So how do we do this? So Shuko has introduced 2 components, out of which the first one is an engagement catch. So the engagement catch basically helps you in holding the shutter when it bangs. So when there is a gust of wind acting on the window, so when it slams, it basically stops it from moving to and fro. And this particular article has been developed with the operation where once it is slammed, when you have to open, you can just use the handle lever and then open it. So this helps you in preventing the stress that is falling on the window because of the slamming to and fro motion of the openables. followed by safety catch. So safety catch is a redundant safety mechanism. So even though you don't have an engagement catch, safety catch is something that we are recommending for all the openables, especially in high-rise buildings, because in the event there is a complete failure of the hinges and the window is dislodged from your outer frame, the safety catch will make sure that it holds onto the window and it doesn't fall down on anyone's head or something. So this has been tested. So initially we don't have anything as of a standard for safety catches. So how do we test? So the idea was to convert the real world scenario into more of a testing parameter. So there is a dynamic wind load that has been tested. There is a sustained loading that has been tested and an impact load. So all this kind of replicates what can happen in a real world scenario. So imagine the window has fallen off. There is no one to look at the building for a couple of days and the window is hanging there. So and still there is a wind load acting on it. So all these three particular parameters help us in achieving what can happen in the real world scenario. So with this, we have converted this as a certain set of testing. So this was the tensile test, which was basically to understand how strong the steel is of the safety catch. The second one was the drop test. So we wanted to see how much weight it can handle. So this is basically what we have done. So as an in-house testing. And then we followed up with the blowout test just to understand the actual dynamic effect when there is a gust of wind acting on it. Right? So this is what was tested in the third-party testing, followed by a dynamic test where we left the window hanging and there was a wind load added upon it to make sure it doesn't dislocate in that severe condition as well. Yeah, so coming to the last part is about sustainability. Which has been a very important part for the Schuko group as well as Schuko India altogether. So what we are currently seeing is India as a country has committed to zero greenhouse gas emissions by year 2070. India's building and construction sector increasingly focuses on sustainability, energy and green certifications. Along with this, there is a rapid growth of high-rise commercial and premium projects, and this is going to have an effect on what India is planning to achieve by 2070. Aluminum systems, when we talk about aluminum systems, they are widely adopted for their durability, performance, and recyclability, and this is where the sustainable picture actually comes for Schuko as a company as well. So when we move on to what Schuko India actually wants to do is, so this is where we were in 2019, roughly around, I would say 4 kg for carbon emission was our count. And currently we are at around 22.3 as of now. So we are currently somewhere here, 22.3. So with this, what we have initiated is, if there is no action taken, we will probably end up 5.5x times of what we were in 2019, right? And what we want to achieve through our sustainable approach is x by 2 of what we were in 2019. To achieve this, we have introduced something as Schuko Green Aluminium. So Schuko Green Aluminium is the raw material which we are basically developing through a very sustainable process. It has low carbon aluminium, which can be up to 5.8 tons carbon dioxide emission, and then we have ultra low carbon, which is at 1.5 T. So there is the complete ultra low carbon, which is a 100% post consumer recycled input, which is, again, we have got this EPD verified, and we have the certificates also available. So basically through this, through sustainability and engineering optimization, we are trying to reduce the carbon, embodied carbon that is going into your facades by a considerable margin. Yeah, so this gives you an edge over getting LEED, Graha, IGBC and EDGE certifications. And with this, it has been a milestone for us and for India as well, that we have been able to get the first low carbon project here in India, where we have been able to successfully reduce the overall carbon dioxide emission from 20 to 24 kgs to around 6 kgs of carbon dioxide emission through our green aluminium offering. Yeah, so with this, we are getting down to up to 75% of the embodied carbon. So yeah, this has been a stepping stone for us. This is the first step that we have taken up, and we intend to make it bigger in the coming years so that there is more green aluminium and more sustainable facade buildings in the world. right? So with this, I just want to close my presentation saying that at Schuko, we are invested, we are dedicated in giving the architecture, giving a performance-based and a very sustainable solution to the facade industry. Yeah, thank you. Thank you for your time.
Thank you, Mr. Harsharaj, for sharing the latest innovations and impeccable standards of Schuko. Ladies and gentlemen, coming up next is our keynote speaker all the way from Singapore. Let's give a round of applause to welcome Mr. James Tan from Wow Architects.
Hello, everyone. We are witnessing one of the greatest paradoxes in human history. As our cities continue to rise, the living systems that sustain them continue to disappear. This is Southeast Asia. Right. And it's home to some of the richest tropical ecosystems on Earth. Yet it is also one of the fastest urbanizing regions in the world. So perhaps the question is no longer whether we should build. The question is how our buildings can become part of the ecological systems they replace. For more than a century, we have treated architecture and ecology as separate disciplines. Architecture builds cities. Ecology protects nature. Then perhaps this separation is a problem itself. This is the crisis of disconnection. Architecture has become increasingly disconnected from the living systems that once shaped it. Architecture is ecology. This is the central idea I would like to share with you today. Ecology is not simply about forests. Ecology is the study of relationships. The living facade becomes a threshold where these relationships are created, restored, and regenerated. So for far too long, we have understood facades as the line that separates human from nature, a protective layer between the controlled interior and the unpredictable exterior. So, but what if the facade is not a boundary? What if it became the place where relationships are restored and repaired? So at WOW, we see ecology not simply as plants and biodiversity. Ecology is the study of relationships between species, climate, culture, memory, emotion, and time. A truly regenerative facade is therefore not the skin of a building. It is a living interface. It is the threshold where architecture begins to exchange with life. The word exchange is particularly compelling here as it captures the essence of reciprocity. A living organism is alive because it exchanges energy, air, water, nutrients, information with its environment. But by analogy, a living facade should exchange light, air, views, energy, biodiversity, culture, memory, and human experience too. It's not simply a high-performance enclosure. It is an active participant in the ecology of relationships. Today, I'll be presenting 3 aspects of this ecology through 3 projects of WOW. Our recently completed Mandai Rainforest Resort by Banyan Tree in Singapore. Please do visit it if you're dropping by in Singapore. The Residency Signature in Madurai, very close to Chennai here. And the Alteza on OMR in Chennai. So a facade is not an external expression. It is the visible memory of invisible forces that shape it. One of our projects that speaks about this, the ecology of place, is our recently completed Mandai Rainforest Resort by Banyan Tree that sits adjacent to the Singapore Mandai Wildlife Reserve and the Upper Seletar Reservoir, our nation's drinking water. The site is surrounded by significant ecological assets, including the Singapore Zoo, the River Safari, Night Safari, with 6 new attractions and extensive secondary rainforests. It is part of the Mandai Rejuvenation Project to transform this 126-hectare site into an integrated eco-tourism hub. And the Mandai Rainforest Resort is the crowning jewel of this transformation. Most projects begin with building efficiency. Mandai began with ecology. Rather than clearing the site, we first understood its existing ecological systems and designed around them. The architecture weaves through the forest like a liana, becoming part of the site's ecological infrastructure and creating conditions for nature to regenerate and thrive. The result is that there is no singular or dominant architectural form to the resort. Rather than imposing an object on the landscape, the architecture behaves like a liana within the rainforest, threading, bridging, and linking together the spaces between existing trees, habitats, and ecological systems. Every one of the site's 25-meter-tall signature trees was conserved. It takes 10 to 50 years for a tree to grow from 2 meters to 20 to 50 meters. We have to preserve and conserve that and treasure that. So rather than asking the forest to make way for architecture, we ask architecture to make way for the forest. The result of which was that these signature trees became the ecological infrastructure of the resort. And this also became the foundation of the facade's ecology of place analogy and strategy. So for those trees that we could not save or retain, every one of them was given a second life, upcycled into facade elements, interior finishes, and furniture throughout the resort. So rather than imitating the forest, we allowed the forest itself to become part of the architecture. Here you can see the bark and the lianas were carefully composed to create masterful patterns for the facade precast panels. Our founder, Mr. Wong Chu Man, and our project director there, very hands-on, personally involved in this process, treating each panel almost like a piece of art. The intention was never to create a decorative facade. It was to capture the memory of the forest, to allow the architecture to carry forward the textures, scars, and stories of the trees that once stood on this site. The bark and liana compositions were transformed into full-scale molds for the precast concrete panels. Each panel was prototyped and refined in Singapore before installation, ensuring that the intricate textures of the forest was faithfully preserved. In this way, the facade became more than a building skin. It became a lasting imprint of the rainforest memory. The level of detail captured in the bark and lianas is really extraordinary. But this is not biomimicry, right? We are not imitating nature. We are preserving its memory. The facade becomes a living archive of the forest. And in this way, the forest was never lost. It simply changed its form. These precast panels were integrated along the naturally ventilated breezeways, framing the rainforest and establishing the architecture identity of the resort. So rather than enclosing space, the facade choreographs a continuous dialogue between architecture and nature, transforming every journey through the resort into an experience of the forest. So if Mandai is about remembering the forest, the Residency Signature Hotel in Madurai is about remembering culture. It explores another dimension of the living facade, the ecology of place, right? Where architecture becomes a living expression of the city's memory, identity, and spirit. Right? Located in Madurai, this temple city of Tamil Nadu, the hotel draws inspiration from the city's rich cultural heritage, allowing the architecture to become a contemporary expression of the ecology of place. So the facade is not a literal interpretation of Madurai's temple architecture. It's a contemporary expression of its cultural intelligence. It draws upon the rhythm, depth, hierarchy, and climatic wisdom that has shaped this sacred city for centuries. The cascading bougainvilleas completes this narrative, chosen not only for its resilience in Madurai's hot, dry climate, it also carries deep cultural and spiritual significance, symbolizing hospitality, prosperity, and the welcoming of visitors. Together, the architecture and landscape form a living facade where culture and nature are not separate systems, but part of the same ecology of place. So, second, how can facades reconnect us with the living world? Returning to Mandai, beyond preserving the memory of the forest, the living facade cultivates an ecology of coexistence. It's no longer a boundary separating architecture from nature, but a living threshold that restores the relationship between people, wildlife, and the rainforest. Here, architecture is no longer an observer of nature. It becomes a participant within its living systems. The planting strategy was driven by ecology rather than aesthetics. Plant species were carefully selected according to the microclimate conditions of the facade, sun-loving species on the upper levels and shade-tolerant species on the lower levels, closer to the forest floor. In so doing, the facade becomes more than just a green wall. It becomes a vertical extension of the rainforest, creating habitats for birds, butterflies, and pollinators, and allowing the building to participate in the living ecology of the forest. The trailing vegetation serves a dual purpose. It provides passive shading while helping to reduce bird strikes by making the facade more visible to birds. More importantly, it reflects a fundamental shift in thinking. Rather than designing exclusively for human comfort, we begin to ask a different question. Who else are we designing for? At Mandai, the living facade recognizes that people are only one species within a much larger ecological community. One of the defining features of the guest room is this fully openable facade. Behind an automated mosquito mesh, the entire facade opens to transform part of the room into a semi-outdoor veranda overlooking the rainforest. More than a design feature, it restores a relationship that modern architecture has largely lost, the relationship between people and the climate. Guests are no longer separated from nature by glass, but invited to experience the breeze, sounds, and rhythms of the forest in complete comfort. So perhaps true luxury is not about controlling nature, but about reconnecting with it. The ecology of coexistence is not confined to the natural world. It is equally relevant in our cities, in Chennai, where architecture, the responsibility to reconnect people, not only with nature, but with one another. So at Alteza, on OMR in Chennai, we asked a similar question. Can the facade cultivate the ecology of coexistence within a high-density urban environment? So instead of treating the facade as an edge of the building, we transformed it into a vertical landscape of shared gardens and community spaces. These step terraces create opportunities for neighbors to meet, work, exercise, grow food, and celebrate together, restoring the everyday social interactions that are often lost in contemporary high-rise buildings living. So rather than concentrating communal life on the ground floor or on the rooftop, we distributed it vertically throughout the facade, where every terrace has a different purpose and program to be catalysts for social ecology. Learning, wellness, celebrating, urban farming, the journey through the building becomes a journey through community. Alteza was launched in 2021, and the living facade now weaves through the building like a green spine, bringing nature into the heart of everyday life and allowing the ecology of coexistence to flourish. So we have seen two themes of the living facade, right? The ecology of place and the ecology of coexistence. So what does this all achieve? The answer is regeneration. How can cities and buildings contribute to the ecosystems they inhabit? A living facade is not completed when construction ends. It begins its life when nature, people, and time starts shaping it. For decades, we have spoken about sustainable cities. Well, Singapore has actually taken a different position. Rather than becoming a city with nature, Singapore's vision is to become a city in nature. The subtle change represents a profound shift. Nature is no longer an amenity. It becomes the organizing framework for the city. The question for us as architects and designers and fabricators and consultants is no longer how do we make buildings greener? Rather, it should be how do our buildings actively regenerate the urban ecosystems? So one of the most meaningful ways to measure regeneration is to ask a different question. Who returned because of the project? And beyond that, because this building now inhabits this place, have the environment, the community, and the relationship between people, place, and nature become richer than they were before. For Mandai Rainforest Resort, we started to see weaver birds nesting within the facade, butterflies, monitor lizards, long-tailed macaques, even ospreys. These species are not visitors. They are indicators. They tell us that the building is functioning as part of a living ecosystem. Where wildlife chooses return, architecture has begun to regenerate. And this is also what we hope for Residency Signature in Madurai as well. So if they choose to return, perhaps then we have designed something worthy of being called regenerative. We believe our city should also function in the same way. The living facade in Alteza therefore becomes more than just environmental infrastructure. It becomes a catalyst for coexistence, strengthening the relationships between people, nature, and community. Ultimately, we see architecture and its facade not as a finished product, but as a living substrate from which nature, culture, community, ecological processes, and regenerative systems can operate. Regeneration is never achieved through a single sustainable feature, right? It emerges when every design decision performs multiple ecological functions simultaneously. A green roof does more than reduce heat gain. It restores habitat and strengthens biodiversity. An operable facade does more than reduce energy consumption. It restores our relationship with climate, improving comfort, well-being, and our connection with nature. Trailing vegetation does more than soften the building. It provides passive shading, reduces bird strikes, and transforms the facade into an ecological infrastructure. None of these strategies work in isolation. Together, they create a living system where design, engineering, and ecology no longer operates as separate disciplines and entities, but as one integrated, regenerative system. So, architecture is ecology. The living facade is its living interface, creating, restoring, and regenerating relationships between people, place, and the natural world. Because the future of architecture and our lives is not about building more, it's about belonging more. Thank you. Thank you.
Thank you so much, Mr. Tan, for that incredible talk on ecology of place, coexistence, and regeneration. Truly inspiring and needed for the future of this planet. Moving on to the next session, which is a panel discussion, I would like to welcome the moderator, Mr. Subaya, from Dias Design Consultants, and our esteemed panelists.
Some special treatment, I guess. You and my. Hello, hello, yeah. Yeah, I've got it.
Hi, Prasad. Hello, Gurunath. Prasanna.
Good morning. I think it's more appropriate to say good afternoon. I'm Subaya. I'm your moderator for the afternoon. And I must say it's a tough act to follow, Mr. James. Very impressive presentation and more impressive work as well. And thank you for that. It was a very, very enlightening session. And I must tell my fellow panelists that this is going to be a tough act to follow. But yes, let me quickly introduce the panelists for the afternoon. We have Suraksha from Midori Architects. Could you please join us on the stage? Mr. Gurunath from UA Design Studio. Could you please join us on the stage? Prasanna Kesavan, Studio 7. Mr. Kosal Ram from InfraBees Project Management. And our final panelist, Mr. Sripal. Sir, apologies for taking your seat today. He is usually the moderator in all our events. Good afternoon. We have an interesting subject. I think we had a fantastic introduction for the subject already done by Mr. James. Influence of design in the performance of building envelopes. Now, this is a very interesting subject because there was recently, I did have a conversation with someone where we're trying to explain that facade is not the mask that you put on a building. It's not your Mission Impossible where you just take it off and you put another one and you're a completely different person. There is a big design angle that comes into it. Different architects have different ways they approach that design and how that influences the building performances. And we just heard one side. We have 5 more people who could tell us how they would look at that part being there. Oh, I see I have a timer. So I request the panelists to be on time so that we can wrap it up. I think it's a tough session because we have one session before lunch. So a quick introduction on the subject is when we hear the word facade and the design through of the facade, this is one area that we do see a lot of interface or a lot of involvement of 2 critical entities. One is your designer and the other is the engineer behind it. So this is where almost every line has both entities' contribution. While everywhere else there is a clear demarcation, this is one area that you would find there is a lot of interface, a lot of communication that goes between the 2. So today we are well represented for both, and we did hear about how cost and value engineering comes into picture. So that too is an important factor that goes behind it. So we have a few topics that we want to cover today. I'll quickly move to the key headings that I want to touch upon today. One is, let's start with the first subject. What is performance? Now, performance means something different for different people. So I'd like to know from the panelists quickly, maybe a sentence or two on what in your definition is the word performance means in a facade. Can we start with Suraksha, please, and then we just continue that way. Yeah.
Hi. Good afternoon, everyone. So what we look at in terms of performance is basically a building skin that resolves the climate even before the mechanical and the active systems kick in. So that is what we really look at, and I think in India, the skin itself should be able to reduce the cooling load, it should reject the heat, and it needs to be well aged for the climate in which it's built in. And that's something, to me, that marks the performance of a building.
Thank you. So, what about?
Good afternoon. So to me, performance, how the building is actually, suiting to the neighboring vernacular style. So be it a facade system or the ventilation, how effective the ventilation system is. To me, it's a performance of a building.
Yes.
Good afternoon, everyone. I think to add upon to that, I would say the performance of a building, or rather a well-performed building, means it gives a comfortable environment for the end user. The end user's needs are taken care of. The well-being of end user is taken care of. Be it the air quality, be it the climate sensitivity, and of course the reduction of energy consumption, and as well as the cost saving on a life cycle cost basis, and so on. I think that I would say is a well-performing building.
Mine will be very similar to what my panelists have said. I would say it's a fine balance between thermal comfort of the people that are using, maintainability, then of course resilience, and still maintaining the overall architectural aesthetics over a period of the entire life cycle of the project. That'll be my definition.
The simple answer to the owner, performance means, has it turned out the way it was supposed to? Is it looking good? And are his aspirations adequately captured? To the facilities people, everything that has just been shared by the panelists. Life cycle,
yeah.
Fire safety.
Yeah.
That's a live demo. Okay, so to the facilities and the people who run the entire establishment, metrics, analytics, and bottom line. To the designer, is it a project which captures their design philosophies? So one word means three different things to three different stakeholders for the entire project. So it's a hit and miss. Sometimes you get it right, sometimes you don't. That's always the case for various reasons. It all starts out very well.
So I see that, obviously in this panel itself, we do have different ways, different definitions of the same word, performance. And with user, already there are 3 subdivisions under that based on the user group. So performance is such a varied definition for everybody, be it the end user, be it the designer, or be it the guy who's executing it. For everybody, as I agree, it's got different definition. And among designers themselves, we do see how different people handle it. Coming to the design part of it, the design decisions. When you look at the design decisions, Suraksha, what do you think is the biggest influence in your design? When you're looking at the design for the building, for its performance, what would be that one key factor that you consider while doing your design?
Yeah, so at Midori, when we design buildings, the first thing for us is orientation and form. So if you kind of take care of this, you're looking at least the 26% to at least 40% of the building envelope is responsible for the thermal load of the building. And so taking care of this is just but natural. And in all our projects, we make sure that the climate orientation is first taken care of. There's a project that we recently completed, which is called the Bauer Residence. And it's an IGBC Platinum certified building and pursuing net zero as well. And over there, the facade itself tilts, and there are a lot of overhangs and shading, volumes that kind of bring down, reject the heat. And we early on itself at early stage design from day one, we basically start doing baseline simulations to kind of understand what would a box model kind of be like so that the ventilation can go through. Because these are the two major strategies in tropical climates. And we have a lot of beautiful facade buildings. I mean, the only problem is that we have adopted a model from the West where we have so much glass in a climate which has 9 months of heat rather than 9 months of cold. So how do we actually take care of it? It's orientation and form, and that's what we primarily look for. And it's all about kind of making sure that the facade, people think that the facade is something that you clad on later, but actually it's the first decision that you make in the first 2 weeks of designing any project once you have the brief.
Mr. Prasanna, what is your take on it?
As like what Suraksha was saying, the first and foremost factor would be orientation for any architect. So especially when it comes to Chennai, you try to have less openings or less number of windows when it comes to east and west predominantly, and trying to have larger openings on the north and south at certain point. So in my opinion, when I started designing some of the residential projects, which I am doing a lot, so also with respect to integrating the functionality and Vastu and various other aspirations, what the end users have. So I feel one of the major factor in determining the efficiency of the facade could be the wall-window ratio. So when I talk about wall-window ratio, most often it is seen as you need to restrict yourself at 20-30% of your facade area. That is how it is put it in a very generic way. That is how people try to follow it. I would rather I'm seeing it a little more in depth when I look at it. Rather than generalizing the size as a percentage of wall-window ratio as 30-40% or 20-30% as a sweet spot, I was of the opinion when we design windows of rather thinner and slit windows and vertical windows more often, or horizontal windows, depending on the context which direction the building is facing. And so when we have the strip windows, a lot of these strip windows, it was helping us in terms of reduction of the heat by means of cutting the direct solar radiation, and at the same time trying to have a lot of indirect lighting coming in. So that was the major aspect what I have been seeing. And contextually putting in a lot of these residential buildings, because you can't classify the residential buildings as a air-conditioned building or a non-air-conditioned building, because it is again very contextual and very subjective, and based on the end user it varies between floor to floor and user to user. So what is important for me, I would say, is that the facade should facilitate maximum number of air changes. At the same time, it should cut the direct solar radiation. So in this context, I was able to crack in a good amount of the performance that I'm able to measure over a period of time in most of my buildings. I rather, and to put it in a very simple terms, have more number of smaller windows. It is helping a lot, is the way I see it.
Thank you. And Mr. Gurunath, what's your take on it?
See, normally, before 8 or 10 years back, if the facade was actually added later, the building was done with the plan, the concept, mostly the facade was added much later. But now, with all the parameters and system in place, all the architects, the design philosophy, the design pattern itself is changed. We are keeping the end in mind. We are trying to integrate the systems like the facade systems, the structural glazing, the double walls, louver system, and someone presented the aluminum glass, green louver, aluminum louvers. All this being taken care beforehand, and most of the architects are trying to integrate when they start the project itself, from the conceptual stage itself.
Mr. Sripal, I have this one. This is a very tough one. I think it's a tough question, but probably you might be able to handle it a little. What do you think, when you look at it as a balance between performance and beauty, how do you strike that balance?
Performance and?
Beauty.
Beauty.
Aesthetics.
So, when at the very first meeting with a client, when a project is approached, we ask the client, what do you want the building to be? And we ask ourselves, borrowing the line from Louis Kahn, what does a brick want to be? You can make it a box, you can make it a tessellated, very fascinating construct, you can make it a glass, highly engineered facade, you can add louvers, you can add various kinds of shading devices, but there is beyond that and before that, there is a message which is being conveyed. And that is the identity of the project. That is the identity of the architecture that has been, the responsibility has been given to you. And as designers, we see the future before it happens. That's the gift we bring to the fraternity, and that's a gift we bring to society. We are fortune tellers in that sense, right? Because they don't have the skill or the training or the ability to see and envisage environments 10 years from now, how they will turn up. But we do that because that's what we bring. So beauty is an extension of your own design philosophy. And beauty is an extension of one component of what the architecture is about. Yes, it's the first component that you engage in, but not necessarily the only component. So that's the difference between the skin and then the space. And in our work, both are very, very interconnected. So the skin and the space have a dialogue, and that dialogue is what creates the architecture. So, there are different ways, and there's no right and there's no wrong. They're all good. I think it's the question of discretion and appropriateness. And what is appropriate for a north facade may not be appropriate for a west facade, and similarly for a south. And what is appropriate for the southern hemisphere is not appropriate for Dubai and not appropriate for the western hemisphere. So contextualism, identity, and most important, your own personal belief in architecture are all interwoven in one very
complicated,
one very interesting cocktail. So that's the.
I see how most of our answers are always very complicated, as is our designs. So sir, I would like Mr. Kosalram to weigh in. I mean, being the project manager representative here, where two things which become
he's the one who brings all of us in line.
Thank you. So, there are two factors I think pretty much drives the way you guys look at it as against the architect would be, I would think it's time and cost. So how do you handle a sensitive subject as performance of a facade? How do you handle it actually getting implemented?
The first thing I would look at is, the design intent is, making sure the design intent is maintained. Most of the time, the design is made to be maintained. Budget should be there actually. The clients typically they said, our previous presenter provided a wonderful example on value engineering actually. So to maintain that, value engineering is one issue that comes into play. That is number one. Number two, what happens is the cost comes into play. That is number two. Number three, the contractors are not brought on board early on. Actually, for example, a facade contractor could be brought on board earlier. So that also missed. And finally, in terms of installations, so what happens when it comes to installation, the installation is not of good quality. Facade might be a fantastic design. When it comes to installation, there is a poor quality there. So as a project manager, I would say, we would need to be upfront. We should be brought in earlier in the project. That is number one. Number two, there should be a facade contractor also, or a facade consultant, I would say. And thirdly, the contractor. So these are three main people should be brought way upstream before the project gets too much into the design or the construction phase.
Coming to the next subject, I think climate, but I think Suraksha already spoke about it. So can you continue on the climate part? If you have anything further to add on what you already said, on how you handle especially, in a city like Chennai, where we do have some really severe conditions which we have to deal with, and still ensure that there is comfort. How do you handle it on the design front?
Yeah, so as I already mentioned, for us it's more about the geometry, and then the facade is a resultant of that. It's not like a cladding that we kind of stick on later on. It is an energy decision rather than a design decision. And also the kind of materials that we use on the facade is extremely key. And we try to pick out those that have green trail, something that's FSC certified, which has like a chain of custody, where we can actually understand where this material is, how it's made, and what is the energy unlocked within it, embodied, or its life cycle. And we keep that in mind while choosing, apart from the fact that it needs to stand the test of time, be able to take care of all of the weather elements. And so these are some of the main things that we do. But we also make sure that we add in a lot of atriums and spaces which can actually help with influencing natural ventilation in Chennai, or in Bangalore it's more about daylight. So it's a milder climate, and so kind of how do you bring that daylight in? Do you choose a glass that has very high specification with SSGC and U value, or do you start to play with the VLT and those kind of things? So that's there for climates like Bangalore, and of course the much hotter ones which are hot and dry. You're looking at just basically keeping everything out and as maximum as possible. So it really depends on the brief, the client's brief, how do you bring all of this together and still make it look, like the previous presentation, ecological, part of nature, rather than just glass concrete buildings. And that's something that we're always exploring in meaning and in purpose in all of our projects.
Coming to technology, this I think she was taking it from where she left. Mr. Sripal, and I think I'll pose this to Mr. Kosalram. How do you handle technology? I mean, where do you see technology helping you with the performance of facade now?
Oh, I see a huge revolution in the materials that we have today in comparison with what we had 15 years back. And as simple as if you just look at Shuko's earlier presentation, the mullions and the transoms which we were dealing with 15 years back, and now the elegance, the strength, the closeness to the design intent is possible because of advancements in everything. The mix of the metal which is created as opposed to what was done 15 years back, the strength, the merging of industries. The year 2000, Bilbao set, I think, a paradigm shift, a game-changing example to the world. Frank Gehry married CATIA technology, which is used to design fighter jets, right? Dassault Mirage is the origin. So that technology entered into mainstream architecture to create geometries which were unbelievable, which were only in science fiction and in Hollywood movies. And this became a living reality. Now, how do you think all that happened? And all from what I remember reading, and the entire construction team was forced to use the same CATIA technology even to make the working drawings, so that every curve, every parametric, nodes, whatever, everything was captured exactly the way it was created. So that's the year 2000. We are in 2026. 26 years of advancement in building materials, in structural engineering, in the way of thinking. I think it's only a matter of time before we have breathable facades. Graphene 3D is going to make an entry mainstream, and then it's not just a photovoltaic panel on the facade, it's actually a facade which will absorb temperature and start working the way marble did for the Taj Mahal, where it's keeping summers cool and winters warm. And now imagine if your skin starts doing that, and you still get the benefit of ventilation and everything else that we are dealing with. So I think every year, now it used to be every decade, now it's literally on a year-on-year basis. There are new grounds and new worlds to be discovered. And it's getting only better, but it's also the affordability. Today, people have money, and people have the vision, and people have the awareness and the conviction to spend money. So all of this would not have been possible if we were, straddled with cost. And so it's a huge opportunity, but it's also a huge responsibility, and they go hand in hand.
And if I can add to that,
sorry, please go.
If I could add to that, also the fact that there is a need in the market for more sustainable materials. I think the industry is going back, doing R&D and looking at ways in which new materials can be recycled and used rather than just go back to the infinite taking from the earth, So they're looking at novel ways of re-engineering, pre-engineering and all of that, which makes it not just anymore in ESG compliance, but something that people are genuinely interested in seeing and using in their business.
Oh, absolutely. I mean, it's a whole holistic philosophy which is now percolating in every aspect of our lives.
Circular economy, right?
Yeah, I mean, I think the important topic that came up was reduction in carbon footprint or embodied energy. So, obviously these all come with a cost. So how do you see this angle?
Going back to the topic that you asked, parametric facades are very
exactly,
popular.
yeah. So automation and parametric facade. How do you see this? Because from how we see projects run, we see a lot of influence on the project manager's views on these things with the client. I mean, obviously the client has you on board as an extended arm. So how do you see these aspects, that is technology and automation and transformation that we are seeing on things that were a dream maybe 20 years, 25 years ago, as he was talking about. How do you see and how do you prep your clients for that?
That is a tough one, actually. So 20 years ago, I used to work in the US and I thought, facade design was such and such. But today, looking at all the projects right now here in India, it's amazing. There's so much of transformation that has happened in the last 15, 20 years. So I would say, we are heading towards something called the living building. The building was, it starts living by itself. It's so much of green and as a breathable building by itself. One of the key issues the clients have is the cost ROI. So ROI is main, actually. If you can convince the client saying that the return on investment is there for your building, definitely he's going to invest in those facade, whatever the design may be. So that will be my response to that, actually.
Mr. Prasanna, where do you... Sorry, please go ahead.
And that convincing happens on day one. And that's really important when we talk about budgets. Like if we could just give them that awareness down the line, downstream, you won't be having that conversation. I think architects are responsible in this, disseminating this message.
Mr. Prasanna, what would be your...
Speaking about ROI, the return on investment, see, there is two aspects to it. Like when you get into the project, people talk about the CapEx, the initial capital expenditure. And when you run the project, as you keep moving on, people are worried about the OpEx. So I would say more than looking at the CapEx, the clients have to be really worried about the OpEx, especially when it is commercial buildings like malls and hotels and so on. One way technology is really catching up fast is this concept called digital twin, where there is a series of IoT sensors plugged into the systems of the building. And each and every aspect of energy systems and be it the HVAC, be it the electrical system, everything is monitored on a real-time basis. So this system works like a complete digital replica of an existing physical property. So the client is able to ascertain, analyze, and dissect information on every single perspective, and they're able to see whether the building is really performing or not. So I think digital twin is one such thing which is shaping up really well. I also want the audience to take note of this, because we are in an era where digital twin systems are kicking in, and I think the next 10 years would be a lot more things to do with digital twin systems.
Mr. Gurunath, what do you see?
So I would like
what is
to
your take on this subject?
On the technology part?
Technology, cost, the next big thing.
Okay, regarding the technology, there was one project which we discussed with the green consultant a couple of weeks back. The way in which he had incorporated the technology, he said that, Guru, if the building is now north-south orientation, if you rotate it by 15 degrees, this is the heat, the dissipation you can anticipate. So that is, in fact, a game changer for me. In fact, we wouldn't have anticipated the building to be, we wouldn't have designed it in such a way that they had presented me a software, but there was one problem with that. I told him the Vastu will have to check. Otherwise, I was completely mind blown with the way in which the technology comes an active part in even the orientation of the building, the incorporating of the facade elements there. And he also mentioned that if you have some greeneries across the southern area, because we know that the southern western side we need to have greenery, but in the model he had showed us that if you had incorporated this height of a greenery there, then this is the kind of heat you're gonna, the direct solar light is gonna reduce in that, and the building is going to be performing much better. So it was a complete game changer for me. Another project I would like to mention here is the project which we have just completed in Karaikudi. Taking from the cues of the traditional building there, the library, we have designed a courtyard. It's a double-height structure with a natural ventilation in the clay story. And it had taken care of the ventilation aspect also. And apart from that, we had introduced some louvers, aluminum louvers on the western and southern side. It had in turn cut down a lot of direct sunlight. It actually given a natural ventilation to the entire building. So probably some passive design features like that, along with the right technology, I think should be the game forward.
So when you're looking at, we are also excited about technology and the new age. How do you each handle making sure that the cultural aspect of the particular region and responsiveness to the culture because India is so heavily driven on culture, and there's so many vernacular aspects. How do you see that being preserved while we are adopting these new age technologies, new age? I mean, I agree. Every year things are changing. So and everything is changing so fast, how do you keep a certain constant like the vernacular part?
We have brilliant examples in front of us. If you see Masdar in the Middle East, and that is designed by Norman Foster, arguably the most prolific design office out of the UK, and with Norman Foster's repertoire of projects, futuristic buildings, airports, you name it, everything is done. And then what he did for Masdar was he adopted an identity which was connected to culture, to the land, to the building materials, and the historic reference, but in a brand new, highly engineered solution. So it comes down to eventually choices which we as designers make. And what do we want to do? You want to make a super efficient, futuristic building, but cloak it in a message in a very culturally relevant skin, or do something much more than that. And I mean, just imagine, Ahad is here in the house, it's an idea. I'm just looking at all the cities where the events are lined up. What if he were to get James Cameron, Christopher Nolan, and Bjarke Ingels, and you take Lord Foster in one room and talk about exactly what we are talking about, the future of architecture, future of skin, and how do you see the transformation? Because remember the movie Minority Report? When it came out, today all of that is what we are using, whether it's in our phone or whether it's in our bathrooms or whether it's... So the world we are living in right now is actually the fabrication of a world which was imagined earlier, and applying that same paradigm and that same logic, the world we are going to inhabit 10 years from now is already thought of, and it's just waiting to be played out. So it's all very, very interesting if you look at it from that point of view. But I say we live in an age of flux, we live in an age of promise, and we live in an age of experimentation. And at no point in time have we been experimenting more than what we are doing now.
So if there was one material or one product or one technology that you've got your eyes set on, it's not there yet, but like how LED was when we were in 2004, 5, the idea of selling an idea of an LED itself was tough. Today, it's a no-brainer. I mean, you don't have LED lights, what's wrong with you? So is there a product or a technology that you see now that, I think Mr. Prasanna already talked about digital twin on that. Is there anything else that you think, keep your eyes on this, watch out for this thing, it's going to be really big in our industry, in the construction industry? What would that one technology or one material or one product or that you think you have your eyes set on for the future?
I think 3D printing. Yeah, 3D printing in the roll form, in the sense that we can actually, root out all of the time that takes to complete the project, which is where most of the cost as well goes. So 3D printing in terms of feeding everything in. I'm not saying eliminate the contractor. I'm just saying speed up the process, because we know that end of the day how much technology we have and how much ever simulation and software, like you mentioned, CATIA and Rhino and Grasshopper, all co-simulation, new plugins coming in. You can't erase the human element. That's always going to be just faster ways of getting options, but you're still going to have to make that decision from a point which makes sense. And so one thing that I think can help a lot would be 3D printing, for us especially.
To me, it's a kinetic architecture. There is a project in Dubai. I think most of the people would have seen that. The facade system, it's kinetic. It moves, it adjusts itself towards the position of the solar angle or the ventilation. So I think probably that is one of the key factors which we have to incorporate. I think I have not seen any of the buildings incorporated in India as of now. I think that is one area where we should keep our eyes on, the kinetic architecture.
So I think going forward, these plugins, right now we are using a lot of plugins for CFD analysis and wind analysis and all that, wind tunnel analysis. I think going forward, all these things would get seamlessly integrated in our drafting softwares and visualizing softwares is what I feel. That's going to be the next thing.
I would say AI in building envelope maintenance. Where will you get all the labors? If you don't get labors in the next couple of years, it's going to be very difficult to get maintenance staff to maintain your building. So that's where AI comes in place, and you can already have your systems in place so that it automatically maintains the facades and everything. So that's what I would recommend.
Engineered ceramics. Looking at the way we are dealing with global warming, if there's one product which is actually working to counter that, engineered ceramics. And then application of that, see, the UN Studios building in Dubai, when we were there, it was under construction. Now it's actually completed, and all the data is out there for everyone to dissect, trisect, do whatever it is and see. So engineered ceramics, that's the, that would be my call.
The future of facade with engineered ceramics.
Yeah, because it straddles cultures, and it straddles geographies, and it straddles abundance. We're going to have tons of sand, which is going to be available with water scarcity. So yeah. But we still need to build, and we still need to live, and then it has to be energy friendly and everything else. So
I request Zach to keep this forum back in 10 years' time. So we'll just re-verify if any of these predictions do come true, because we do see that's one thing that we all see, I think we all agree on, is the change is so rapid. The change is so rapid in the last 5 years or 10 years. It's only looking to be picking up pace going forward. What we saw in the last 10 years, I would think, I wouldn't be surprised if we see that amount of change the next 1 year or even lesser. So I think as designers, adaptability and being responsive to the new things that come in, at the same time keeping on board what we've learned as roots of our culture, our city, our country. If we can preserve a part of that while these changes come about, and make this change a constant, but at the same time evolving with what we already know. I'm very excited about where the country is heading, where the state is heading, and where we all heading together as architects. I'm very thankful for all of you for being here, and I would like to thank Zach for having us all here and having this session. I think we have 2 minutes left. So is there any one catchphrase that you would want to conclude with, one tagline for performance of facade. Please, each one of you can, one tagline. If you had to talk about the future of facade and performance of facade, what would be that one tagline? Let's be marketing guys for a second and come up with one tagline for each of us.
One tagline, I would say, for sustainability, there is no knowledge gap, there's an implementation gap in our country.
Okay, the performance shouldn't be only during the inauguration of the building. It should be throughout the life, cycle of the building. Probably it is maybe 15 years, 20 years throughout the lifespan of the building.
Taking a cue from there, durability is the real beauty.
Should be a living facade for me.
Keep learning.
Thank you. With that, thank you very much. And we'll break, I think, for lunch. Thank you very much for that. Thank you.
Thank you, all of you, for that great session. Yes, we will now have our lunch break, and it'll be for about 45 minutes. So we'll see you back here at 3:25.
Yeah, hi, good evening, everyone. I'm Durgai from FST. It's a Hyderabad firm, mostly focused on residential and hospitality buildings. We do have done all the high-rise buildings, but now I'm going to talk about what I'm obsessed, and most of the time I'm working on these kind of projects. It's thanks to Zach, and it's an honor to present our work here in Chennai, the city I grew up to become an architect, and we are indebted to the people who mentored us in our formative times. I'm always interested in how the built environment is inherently contextual and relational. Space as a continuous and interconnected field, one that challenges the fixed inside-outside demarcations and dissolves the boundaries that is rigid to become one. Through our these are the different projects which I'm currently working with, almost 10 of them. Mostly focus on farming and living together, focusing on collective, responsible and sustainable living. Currently we have developed around 10 projects, out of which 4 are completed and the others are ongoing. So it varies from a low-rise villa community to a mid-rise apartment. Sorry. This is our recently completed project called Organontaram. It's a 180 family community designed based on the hydrological conditions of the site below. The site below and above, and develop its master plan for a water positive ecosystem. It's a cluster planning encourages the neighborhood street culture that allows people to socialize and engage. On the right hand side, you see the development in 5 years from an abandoned farmland into a thriving biodiversity, diverse ecosystem. These sustainable projects, most of them, focus on 7 aspects like net zero in terms of energy, water positive, for passive systems, for air and ventilation, people and pedestrian centric, native, organic farming, etc. You can see the material palette enriched with locally sourced recycled materials, site quarried stones, terrazzo, mud plaster, and sustainable construction methods such as filler slabs, bamboo, and thatch. I would like to show similar projects. We approach them in an ecological way of thinking. Here is the engraving, shows that the front page of Marc Antony Logia's book called Essays in Architecture from 1755. It's urging architects to shed decoration and go back to the essence of the primitive hut. That's what the picture is showing. So what interests me in this is if you notice, what interests me in this is the woman who represents architecture, and she is pointing to a primitive hut, almost merging with nature, that is. In her other hand, she holds measuring and drawing tools. This signifies architecture is all about how we measure and control nature. My interest is in this juncture of architecture and nature. One is about control, the other one is about wilderness. Conceptually, architecture always resists wilderness and stays calm, control, leading to an isolated system. Here, we have attempted through certain methods and strategies to bring these opposites into a reciprocative system that flows from one onto the other, like our traditional environments. So these are design strategies as an ecological spatial framework that reconfigure the relation between the exteriority and the interiority, allowing built form, landscape, climate, and inhabitation to operate as a reciprocal spatial continuum. This condition helps to completely reinvent the relationship of architecture with nature or outside, vice versa. My first method is called street. In traditional environments, the house has elements of a street that allows the inmates to interact and actively engage through like Mutram or the central courtyard, and the street has the components of the house or an extension like Arugu or Thinai that spills over the street and activates it. So here is the project called Organo Antaram that I introduced earlier with sustainable development with cluster neighborhood living, where I explored the idea of how the street can become a house. A community of 182 homes are scaled down to a walkable communities of small, called Palais, hamlets, interspersed with farmlands and green corridors. The streets of the Antaram are not considered as a mere thoroughfare for convenience to reach the houses, but an active social realm where the first encounters happen outside the boundary of private spaces in the public. The clusters are scaled to 20 units, which is walkable, around 150 meters long, and staggered with two typologies to create various levels of interactive zones to encourage multi-scalar and temporal interactions mirroring spontaneous layered social life of rural India. The streets acts like a Petta Illu, that is called in Telugu, the courtyard house, with a central community space where each residents have a sense of belonging to the neighborhood as a family. Each hamlet, street clusters are organized with unique programs and create unique identity and encourages an inter-cluster interactions across community through connected pedestrians and jogging network. Here is one of the cluster. It is an outdoor performance, and the other one is more like an indoor activity. Some other cluster, it's a play and a gathering. So it has its own identity of each of them. And streets draws inspiration from traditional Arugu or Thinai spaces, where open structures extended from houses into the street, creating a fluid connection between private and public spaces. This continuity allows the street to become an extension of the social realm, much like how verandas in traditional homes blur the line between personal and communal spaces. This is a project which I'm talking about is a high-rise building, which is around 200 units approximately, community. It's called Together Men's Tula. It's located in Bangalore. We explored this idea of the street becomes a part of architecture, how that is possible. So we have a question, what if we flip the natural, multi-generational and active social engagement and horizontal connectivity of street experience into a vertical architecture? To create this strong connectivity between all floors and ground and roof, the design exploits the two inner corners of the tower to become community space coupled with elevator lobbies. This forces people to move through them both horizontally and vertically. The tower open spaces are positioned in a way that physical and visual continuity of activities integrated seamlessly. Spaces are fluid from horizontal to vertical, yet experiences feel unique every time we pass through them. The sectional porosity allows the people, air, and light flow through the built environment. The green buffer on the ground creates a cooling effect over the wind, allow them to pass through the built environment. These three-dimensional streets become expressed as architectural volumes, giving an immediate identity to the project. The two vertical streets are further designed to have different character and program in each of them, one being more active, playful, high on interaction, while the other is a more intimate, quiet, and introspective. The experiences are also enhanced through materials, color, and level of transparencies between these floors. Here is the active program distribution across the vertical street. Through multiple levels of these activities and variations, increases the chances of serendipitous interactions between the residents. The active programs like sports, celebrations, and workspaces are organized along vertical street, making them easily accessible, exciting to go, and convenient to suit work style and need of a privacy. So here is the passive program distribution along the vertical street. Allow multi-generational interactions like elders' leisure zones overlooked from a youngsters' cafe, music and dance, things like that. And in the upper levels, the biophilic green environment and upper levels, where the vertical gardens backdrop with filtered light and air rejuvenates the space. At the top, the solar shaded roof offers a work lounge experience among square foot gardens to take advantage of the pleasant Bangalore weather and the scenic views to the city. Here is our next strategy we call it as fields. We explored this in a project called Organo Antaram. It's Organo Antaram's Rurban Hive, that is a social hub of the 180 Farm Villa, which I explained in the beginning. Here is the painting by Peter Bruegel, a late Renaissance response from the Northern Europe. Unlike Renaissance artists, his composition lack any single focal point, but are made up of many competing figures and objects, all rendered more or less equally and require the viewer, not the artist, to select what is important to focus on this field of activity. So from this, instead of approaching the building as a single entity, I simply distributed the program along the water channel with shifting orientation. The programs are juxtaposed across landscape that creates a seamless interrelationship with nature and water channel. The roof floats over the landscape with the shifting silhouettes represents the village home. The overlapping roofs allow a stack effect to escape the warm air and make the alfresco open programs more conducive with the evaporative cooling. The roofs are simple and lightly held up by these thin structural elements, almost look like floating, juxtaposed with multiple roof orientation, creates pleasant surprises of interacting roof elements in different angles. Interlaced with the landscape, transfers to interior and exterior, and vice versa with ease. Here, again, in a project called Organo Kandavada, for the clubhouse, which is the heart of the villa community development. We try to work on the same idea of distribution of programs across landscape, topography, than treat them as a single entity. Users here, the users are allowed to explore their own path while traverse through the landscape to different aspects of the program. Got inspirations from the rocks of Hyderabad. I recreated this kind of a in-between transitions and spatial conditions. The form of the building hint at the mounds of the landscape, which are usually undomesticated lands of Hyderabad that emerges out of the ground. The floating objects signify the sports room and alfresco as a meeting point and act as a landmark over the mounds. Like a tree canopy with a live green facade that will allow shade, cool down the space, create a sensorial experience. We can see the distribution of programs along both sides of the channel, active programs, and it's called sports activities on the left-hand side, and the calmer programs towards the right side. This is the site is under construction. The canopy of the alfresco acts as a landmark to orient oneself along the movement paths with the multiple entries and paths. Like a tree canopy with a live green facade will allow to shade or cool down the space, creates a sensorial experience with filtering light and wind under the structure. And this acts as a kind of a symbolic tree in the landscape. The in-between conditions of active programs, side with sports, theater, and pool. The others, the calmer programs, the same in-between conditions between spa and other programs. And these landscape mounts create a privacy moments in between guest rooms units, the overall picture of the project that is under construction. Here is the third method that I call it terrain. In this, I want to explore how we inhabit the terrain like a pilgrim through a mid-rise community development of a weekend studio of 200 numbers called Urban Loft. Focus on health and social aspects of communal living. You know this pilgrimage, most of them are very aware of this. It's a pilgrimage to Sabarimala. So I guess you all have this experience of traveling. Me as well, from my young age, I used to travel with my parents through this place. Though too many times I went, every time it invokes a new feeling of excitement and rejuvenation. The diagram shows the pilgrimage. The journey starts from the right bottom and culminates in the left top. Different activities are marked along the path. The people will perform. Apart from its religious significance, these different activities vary for different age groups, like first time I had old age, and in different time and climate. Sometimes you walk in heavy monsoon, rain, fully drenched, sometimes in fog under a sweating harsh sun. And what interests me is that not only these events happen sequentially in different ways, but also they happen across topography, not just in a single space or a building. Rejuvenation they seek is not just by the culmination of this event, but by the experience of this sensorial active journey taking along the topos. Coming back to the project, in Urban Loft, this diagram shows ritualistic paths that residents and guests take through the site and the building. Here the red dot lines are showing the jogging path organized along with health-related programs such as gym, forest walk, etc. And the pink line showing the social path that are organized along with social nodes such as staircases, gardens, and social programs, cafes, sundowner decks, etc. Instead of having a passive relation to the green outs or a greener or outside, I want to create an active integration between built form and green. With strategic formal edits, both in 2D and 3D, allow the green to flow in between and over the form. These sloped forms facilitate the movement path across the site and building with a seamless transition. The formed slopes allow a stepped landscape for an interaction zone and enrich with different kinds of activity to make it memorable and dynamic. These social and active paths connect different aspects of the program, from a calm, serene forest walk on the right-hand side to camping zone near the pond to the terrace level pool, yoga deck, barbecue, and terrace farming. The solar roof is enough is to produce energy for the entire community, creates shade and brings down the harsh radiation at the terrace level. Here the built form almost submerged into the green, and the ground emerges over the built form like a mound over the landscape. The stepped landscapes activate different levels of social and communal interactions along the productive landscapes and connect ground to the terrace top. These shifting red staircases foster interaction and become an active social space while the residents move up and down to reach the communal garden at lower levels. This is currently under construction on the basement level, I guess. Now this is the fourth method, which you call it as a topological. In this, in a weekend house in Hyderabad, we explored the idea of a undulating topology that facilitates human relationships and integrates seamlessly with its environment. The program of the house is split between sky and the ground, with private moments happen in the floating pod over the undulating ground that hosts his public events and activities. Below the ground, buried, the actual functionality of the house is being modulated and kept fluid. Under the ground programs are kept in an open and a fluid manner that could modulate the roof based on its required volumes and submerge and emerge as required movements to interact with its context for light and air. The central circular cut on the topological ground not only facilitate as a courtyard to allow light and air, but act as an entrance portal to climb down from the mound to enter the house. The structure is a homogeneous panel made into quadrants for easy assembly that would evenly distribute the load across and supported by verticals below. I need 5 more minutes. The entrance is a double light functional and hosting events and happen over the thing, and the green roof that brings down the radiation of the biomass, and the floating parts that is overlooking and has hosting the bedroom and the multi-utility space for the entertainment of a close circle of friends. And then there is an observatory tower that will overlook into the city and the lake. Here is the last one. Here is a project we collaborated with ex-architects from Dubai on 3D printing sales center in Riyadh. We approached a method called spatial implosion. The exact inversion of the idea of distribution of built form and landscape. We have always been interested in the intersection of high-tech and low-tech and how we could combine them to speak of our time and the continuity of the past. And sometimes historic setting seems much more advanced than today's technology. On the right, the Ad Riyadh site near Riyadh showcases the unique Najdid architecture style characterized by traditional mud brick building. It is one of the most celebrated UNESCO heritage sites in the region. It is extraordinary how time and weather have shaped and dissolved these mud structures from their geometric systems to a very fluid and unique architectural remnants. Inspired by this for the sales center model in Riyadh, we explored the idea of using the power of absolute precision to create something that felt unfinished, handmade, and weathered, a way to turn back time and let architecture be a nostalgic cultural icon from the past. Here the walls become more pliable and softer, pushing and bending one another to create spaces and voids. The spaces linked through topological continuity, creating various points of discovery between the programs. The architectural experience continuously flips the boundary between inside and outside, where every program allows one to explore the open paths as much as the internal connections. Like Ad-Riyadh, walls creates a layer that wraps into each other, rising and falling to create entrances, semi-open courtyards, and landscape pockets. Instead of an additional system, we repurpose the idea of shading through density and proximity. That is a very common strategy in vernacular settlements. The spaces formed between the walls were proportioned to be self-shaded to naturally protect the pathways from direct radiation. The walls are spaced, curved, tilted to achieve a higher degree of comfort across different times of the day. The resulting spatial experience is fluid, with pathways that create a heightened sense of discovery, leading from one social space to another. Unlike a courtyard that draws attention, these outdoor spaces become a micro-oasis waiting to be discovered. Each pocket and oasis where the walls dissolve and shifts the focus towards specific experience of local culture, art, and flora. The indoor environments are kept minimal in continuation of exterior and kept in a primordial nature. Humanizing technology through a framework of cultural conditioning and creating a new direction for architecture to take it forward. A direction where new age technology serves to forward the rich cultural traditions that have shaped us as a community. Thank you.
Thank you so much, sir. Very insightful concepts on interconnected inside-out spaces, and your interpretation of art, technology, and nature is phenomenal. Please welcome on stage our next speaker, Mr. Uday V. Shetty from Viva Composite Panel.
Almost good evening. I was supposed to start good afternoon. Happy to present and share some insights here. I'm filling in for my colleague last minute. He couldn't travel for personal reasons. I hope to make sense of the presentation to all of you. I'll be quick because our colleagues in the previous presentation have all covered fire. They covered EPD a little bit, so I'll be quick. It'll be easy for us to do. This is the agenda I'm going to carry up today. So I'll be discussing metal cladding and its contribution to creating sustainable building envelopes. I'll also be talking about the importance of EPDs. We have a colleague or an industry colleague, Mr. Venu here, who's an expert in EPDs, and he can also definitely help us some insights. The benefits of faster turnaround of a project, role of compliance in delivering long-term value to all project stakeholders. I represent Viva. We are a family of about 1,000 people, extensive network all across the world, large warehouses, beautiful colors. I'll sell them later in my stall. So we've spread across the world, almost about 38 countries, and supplied to more than 55 of them projects. So what we are saying is that, of course, EPD is important, but so is important global certifications, global test certification, international standards, and third-party accreditations, because this will deliver the value to all the long-term value to all project stakeholders. If you look at ACM, I'll talk about ACM, which is one of our product line. It's a sustainable product because it's got good excellent thermal efficiency, recyclable, circulability, eco-friendly coatings, lightweight advantage, faster construction, low maintenance, long life cycle. This is the NBCS 2026. I got the name a little long because I think it's actually National Building Code and Standards, right? So they clearly mention, which is the new standard that Suresh Sir mentioned earlier, that 70% mineral core is important and for buildings about 3 floors, and they have to be compliant to ISO 13785 Part 1 and 2. So that's a standard that's now prevalent. Generally, when we are in the pre-coating business or coil coating business, AMA 2605 is very important. It's got various criteria starting from chalking, gloss retention, DFT level, corrosion, etc. So you need to match those to be compliant to AMA 2605. We exceed them. Talking about metal cladding, metal cladding is faster to install, larger panel sizes. That means high design flexibility, enhanced safety because of class A1, versatile finishes because of Viva, supports Rain Green's principles, which is now actively being practiced. We did a study with a fabricator in UAE and India, and we worked on a 5,000 square meter project, wherein we tried to understand what is the cycle of finishing it in a post-coating environment and a pre-coating environment. So based on the fabrication efficiency and delivery overall, we could do it in half the time as compared to a post-coating situation. So coming to EPDs, environmental product is very important. It's a standardized, independently verified document which communicates environmental impact of a product life cycle. It's based on life cycle assessment. It's based on product category rules and verified and accredited by a third party. So we have got a certification of, we have a certified EPD in accordance to EN 15804 because we would like to reinforce our commitment to sustainability and keep giving you products which are more sustainable, or deliver facade solutions which are sustainable. So why EPD matters? Supports green certifications. I think we have some colleagues from them there, that organization as well. Reduces embodied carbon, ensures transparency, regulatory compliance, and of course enables circularity. So we are saying make EPD a practice in manufacturing. Include that as part of your product offering because you'll move from a regulatory to a leadership in a product partnership, in a product leadership. It'll drive credibility and transparency. We're not saying assuring that you'll get business, but you're driving credibility. You're making yourself very transparent to your organization, who's going to buy your material. India's opportunity, India's growing fast. India's constructing a lot of construction happening in India. So eventually we'll have to, India is also committed to be on a certain level of sustainability by 2030. So this will definitely help in the long run. Of course, recognized by green bodies. Impact of EPD on green building. Suppose IGBC GRIA converts that into rating points. But the second point is important. We don't want greenwashing. We just don't want this because we have a product which is EPD certified. But you'll have to look at the applicability. The designers, the stakeholders has to look at the applicability and what does the product offer in terms of points or where the product can perform better. So generally we observe that ACP or solid sheet can go to about 3 to 5 points, but it all depends on the applicability. So the designer, the consultants are very important to derive or use it properly. So the design is the key to using the correct product for the correct application. My colleagues in the earlier presentation have gone through EN 13501, which is to be the class A1 to class B classifications. We have NFPA 285, also a required classification in some parts of the world, not India right now. So when a product is launched, EPD is good, but you need to be globally certified. You need to be matching international standards. You need to be third-party certified as well, because that will give the confidence to the companies ahead or the customers that you're buying to actually trust and invest into your product line. So moving on to Viva. Viva is offering a lot of product lines from ACP to Honeycomb to Solidex, which is the pre-coated solid aluminum, AHPL, ACCP, Lures, fins, baffles. So we are expanding our aluminum footprint. We turn around about 1,500 square meters of 1,500 tons of aluminum every month. So we're using it to expand our footprint into the aluminum business. We have some very good color combinations. These are the new products that we have launched, which is the pre-coated solid sheet, Honeycomb, and the fluted panels. We also have louvers and baffles. We have a stall right across outside this room. Please visit us and give you more details. Time is short here. Some applications of solid sheet. A1 fire safe, that's enhanced safety. Superior structural, so larger panels, design flexibility. Design freedom, so you got colors that we can support you. Long-term value, sustainable, you can recycle the aluminum later. Structural performance, obviously fire safety. Alloys, we can supply in 3003, 5754. So we have an end-to-end solution in our company where we would provide you fabrication support, design support, followed by commercial proposal, then fabrication support, and then also system support. So we'll go end-to-end. Of course, we are NFPA and A1 certified. We have launched the Honeycomb recently, which is the stone honeycomb. It helps us complete the project faster, less weight to be handled, less weight to be moved around, can help reduce transport cost, easy handling. because it's only 6 mm stone and the balance is the honeycomb panel. You can get any finish of stone. You need to just identify the stone and give it to us, and we'll then process it to make it into a honeycomb, stone honeycomb. So, like I said, very interesting. So these are the other products that we run with checkered plate. It's for your public spaces. You have multiple ceilings. Applications. Obviously, everybody knows that the applications of Soidex, ACP, honeycomb is in airports. You have flatter panels, lightweight structure, quick, fast. You like to finish. Nowadays, every month there's an airport or two getting inaugurated. A1 classification for long-term safety. Of course, commercial complexes, metro stations. We would recommend that use of class A1 products where the public space area, which is metro, bullet train, transportation, railway stations. Quickly moving on to some of our very technologically advanced product lines, which is real versus real, how we can transform your dreams into reality. Wood, cotton. We also now started to do parametric design, so we can also give you some perforations, make good designs out of it. I'm going to quickly run through some designs. This is our factory, and these are all made in our factory. Limitless designs you can have. You can pick and choose your own customized design.
Thank you so much, sir, for that great presentation. Our next presenter is Mr. T.S. Aditya from Qtone.
Good evening, one and all. I hope my voice is audible. So the topic for today is sustainable cladding solutions for high-rise buildings. The intent of this presentation is to find the key criteria for material selection for high-rise and how can we make our product sustainable. So historically, if you look at most of the high-rise projects across the world, we have the Burj Khalifa, which is almost around 828 meters. We have Merdeka, which is 679 meters. Everyone knows the One World Trade Center, which is around 541 meters. But in India, primarily, we have three tallest buildings here, which is Palrais Royal, which is around 320 meters and 88 floors. Lokhandwala Minerva, 310 meters, 78 floors. And Piramal Aranya, which is 300 meters and 80 floors. So how do we define a high-rise? A building with an occupied floor that is more than 75 feet above the lowest level of fire department access is defined as a high-rise building. So when we look at sustainable cladding products, primarily what comes to our mind is something like terracotta, which is made up of natural clay, sintered stone, which is made up of clay, feldspar, silica, and all natural materials, timber, which is wood-based, bio-based composites, and of course, natural stone. So when we talk about sustainable products, they should be not only easily available, but also it should have some kind of environmentally friendly nature so that it doesn't impact your environment. Now, the key features of any cladding is, for any selection process, first we like to prefer eco-friendly materials. Second thing is the system, what we adapt in order to fix these materials should be either a rear ventilator or rain screen facade, which improves the energy efficiency of your facade. Third thing is it should be durable and weather resistant, not just the material, but also the complete system. It should be structurally viable. It should be able to withstand different kinds of wind loads. Then at the end of the life cycle of the product, it should be recyclable. It should not have any kind of it should not have a strong carbon footprint. Next is it should be functional as well as aesthetically pleasing. So these are some of the key criteria. Now coming to the key points, for any kind of selection, first thing is when it comes to exterior cladding, we talk about fire. So products which are either A class or B as per European standards as typically preferred for external cladding. Second thing is UV. Most of the products, the issue is that initially in the first 1-2 years, everything looks as brand as new, but eventually we observe that there is some kind of fading, delamination, and probably because of weathering, you have panel to panel color variation. So these have to be addressed. So there's a standard called EN 438 Part 2, which has the stringent norms of testing, and it is accepted internationally. Next is the installation system. After having the right product, in India, we are dependent on a lot of facade contractors. There are very trained seasoned contractors and also upcoming contractors. what is very important for any manufacturer is to give some guidelines which ensures that the contractors follow these guidelines and make sure that it's technically compliant. Every product has certain set of tools to be used. If the right tools are not used, then you can find some kind of edge chipping or undulation or warping that can happen because of improper tools and installation methodologies. All the fabricators and the workers who work at site have to be formally trained by the manufacturing companies in order to ensure that the final output is up to the mark. Most of the facade products adapt the system of rear ventilated facade system, where there's a cavity between the wall and the panel, which is at least 20 mm, and there's a vent on top and bottom, which is again 20 mm. So the concept is that when hot air enters to the cavity, because of low density of hot air, it tends to rise up and exit out from the top. So what we are allowing to do is we are allowing the facade to breathe, and the facade is deemed to be healthy. When there's continuous circulation of air, it keeps the indoor temperature under control. There's an indoor ambient temperature which is maintained. This not only increases your efficiency, but also reduces your decibel level by probably around 8 to 15 decibels. Secondly, the cracks and all are concealed because these profiles and brackets, whatever you use in the substrate, acts as bracing. Third thing is that you can also save a lot on your electricity because of this rear ventilated facade system, which means that it reduces the load on air conditioning. So we were speaking about fire. I'll elaborate a bit more about it. Fire is an exothermic process. To understand the impact of fire on any kind of facade product, we need to understand this graph between temperature and time. So every product undergoes a certain phase of this graph. So if you look at A1 class materials, for example, concrete, or if you look at brick, stone, it doesn't undergo ignition at all. So it's completely non-combustible. It is called A1. So it stops at the ignition phase itself. When you go to A2 class, for example, if you take glass wool is nothing but a mixture of glass fibers which are fixated to each other using adhesives. Now the adhesive can thermally degrade, but the glass fibers are completely fire resistant, which means that certain components of the product can impact because of fire, but the structural integrity of the product remains intact. So this is called A2, which means that it goes from ignition, but it stops at the growing fire stage. It does not reach over to the flashover potential. In class B materials, what it means is that as long as you have the point of application of flame, it burns. The moment you remove the source of flame, it will retard by itself. So in exterior facades, typically consultants prefer which is class A1 or A2, and the worst case class B. So in terms of fire, everyone states a new code, a new norm. Some of them follow European norms, some of them follow ASTM norms, some of them follow British standards. So I'm trying to correlate everything. Here, A1 in European norms is called non-combustible as per British standards. And A2 as per European norms is categorized as limited combustibility. Now, whether it is A1 or A2 in European norms, it is still classified as class A as per ASTM standards. Now, in ASTM standards, you look at something called flame spread index. It's nothing but amount of fire by length of fire. So when you talk about the length of fire, fire propagates both vertically and horizontally. Vertically, it propagates because of material property, and horizontally because of natural phenomenon. So it depends on the kind of product you choose, what the flame spread index is. For example, if you take sintered stone, the flame spread index is somewhere around 10, which is class A as per ASTM norms, but A2 as per European norms. So whether it is A1, A2 or B as per European norms is still classified as class A as per ASTM norms, which means that they are slightly more subtle. So looking at UV testing, this is the most stringent test that is available in the world, that is EN 438 part 2. There's an Atlas testing machine where every product is tested for 1500 hours. And you change the temperature from minus 80 to plus 180 degrees by increasing 10 degrees after every 1 hour gradually. You go from minus 80, minus 70, you go up to 180 and then come back to minus 80 again. So after this destructive test of the product, they look at the degree of fading in terms of appearance and contrast. If the contrast and appearance is above 3 and 4, then it is certified to be an external grade facade product. This is applied to any kind of product. So if something is not having a contrast above 3 and 4 and appearance above 4, which indicates that there is a problem with the product in long-term sustainability. So our product is basically sintered stone. When we tested our panel before the test and after 15 hours, the requirement, as I mentioned, for contrast and appearance 3 and 4, our product has declared the results of 4 and 4. So I can proudly say that our product is sustainable for a longer period of time, and that's the reason we give it warranty of 25 years. So the product that we are promoting, coming to the part, is sintered stone, which is 6 mm thick. It is made up of clay, feldspar, silica, and this is a ceramic product. It is pressed with a pressure of more than 22,000 tons. It is highly durable. It has a flexural capacity of 62 Newton per mm square. So if you look at a normal GVT, glazed vitrified tile, you have binding agents to fuse the clay particles, and you press it with a pressure of around 8,000 tons. The same thing if you increase slightly the quantity of bentonite, and you can apply a pressure of 15,000 tons without breaking. This is called a porcelain slab. Typically, these slabs are used for your kitchen tabletops instead of quartz and granite. The same thing in case if we add titanium dioxide and increase the quantum of bentonite by 12% and change the quality of clay, you can get a complete monolithic kind of product, which is called sintered stone, which has extreme high flexibility, because when you use ceramic products for facade, when you are using a dry cladding system, whenever there's a wind load, there's a deflection in the panel. Until and unless the panel can take some kind of deflection of around 20 to 25 mm, it's very difficult for the products to sustain. That's the reason tiles are typically not the right product for facade, but sintered stone is. As I mentioned, we use titanium dioxide in the glaze. So we use it in the glaze and then we bake it. So what happens is when you use titanium dioxide, the surface becomes super hydrophilic. Second thing is whenever UV light hits the surface, it activates the surface. And the dust, whatever is there on the surface, gets disintegrated and get washed out with rain. So it becomes like a self-cleaning process. Secondly, it converts SOx and NOx into harmless polyatomic ions. So which means that it is a green product, point one. Point number two, if you have 68 poplar trees, which are more than 15 meters tall, the amount of air purification these 68 trees do, the same thing our 10,000 square feet of cladding does. So that's how you can equate it. What are we improving? Whenever there's an opening in a dead wall, and if you use a rear ventilated facade system, because of the chimney effect, the fire spreads very fast. So in case of we need some kind of fire rating of 60 minutes, 120 minutes, we need to use fire stops at all the dead wall openings, seal all the openings, and then we need to compartmentalize the entire facade so that if there is a fire breakage because of short circuiting or whatever, there are a lot of combustible materials in the indoors. When fire exits through a window, breaks the glass and enters, if we have fire stops at all those areas, the moment it comes in contact with fire, this compartment is completely sealed. So the oxygen level goes down and the fire is extinguished in that compartment, not allowing it to pass to the adjacent compartment. So this is a kind of a system that we adapt for fire rating for the entire system. So this is our basic sectional details. Probably I'll be able to brief you better at the stall. We have a small stall there at the corner. So we ensure that the product is not in direct contact with aluminum. We have a male clip and a female clip on the top, male clip at the bottom. They are interconnected, interlocked. It's a complete stress-free system. So we use 100% green fuel. Whatever wastage is used, we use it at Quellet for fuel for heat generation. We use 100% recycled material for packaging. We have our own EPD certification. We got it done and it got published in an international journal as well. We use 50% of water, which is recycled for our internal plant usage. So just summarizing, we are talking about UV resistance, fire resistance, and a modular semi-unitized system because it becomes very fast when you try to install. If you have to just rivet or paste it at site, at that height, it becomes very difficult. So it's easier in case if you can semi-unitize it or unitize it. So we are working towards unitized systems and semi-unitized systems. And rear ventilated facade, as it increases the energy efficiency. No component of the facade should be under any kind of stress so that you don't have to maintain it. So what we offer as iClad is that we offer a complete solution. We don't just supply the product. We give the complete installation system as well. We have our own project managers, so we ensure technical compliance. We just don't sell the product and leave it. So we ensure that our facade contractors and our channel partners install it following all the intricacies and protocols of the company. And we have a very strong technical manual, and we make proper site visit reports, which is circulated to the PMCs, the clients, the facade contractors, and also the consultants, including the architects. So I want to brief a bit about my company. I'm basically from Kuton Ceramics. So we have founded in 2008. We have been there in the industry from the last 18 years. We are the pioneers in producing the largest slab in Asia. So in 2016, we produced 8x4 slab. And in 2018, we produced the world's largest slab of 3.6 meter by 1.2 meters. We started exporting Sinterstone to 12 different countries from 2018. And in India, we haven't launched it formally till 2024. That is last year, because we wanted to launch it along with the complete system. As long as we don't have a proper integrated system, we didn't want to venture into Indian market. The best part is we have our manufacturing facility in Vankaner, which is near Gujarat. We have our R&D center in Sislo in Italy. And all our extrusions are made by ourselves. We have tie-up with various brands like Jindal and Baruka. We give the complete shop drawing, we give the complete structure analysis. We got our wind load testing done at Windwall, and we have tested it up to 4.2 kPa, so we can give you customized solutions for even high-rise buildings. At the same time, we also do small residential retail bungalows where the corners, the edges, the microscopic details are very important. So that's about Kuton, and iClad is a division of Kuton. It's the facade division of Kuton, and we have executed more than 60 projects in India. Our tallest project in India is done in Hyderabad, which is about 37 floors. And we have also done the Chief Minister's office in Andhra Pradesh. So we have done a couple of iconic projects. Looking forward to meet you all at the stall. So if you have any questions, I'll be happy to answer. Thank you so much for your time. Thank you.
Thank you so much, sir, for your presentation. Let's give a round of applause to welcome Mr. Prashant S. Karche from Karche and Associates.
Good evening, everyone. I was supposed to say good afternoon, but it's good evening now. I'm sure after the excellent biryani in Taj, all of you must be in siesta mode, so I'll keep my presentation short and sweet. So I was asked to talk about the phases of architecture, which is basically maximizing the visual impact and the climatic performance of a building, but on a realistic budget. The facade is nothing but the face of architecture in a sense, So in a sense, let me establish one ground rule right away. So the facade is never a wrapping paper. If the floor plan is the brain of the building, then the facade is its personality. It is the building's first handshake with the street, its environmental filter, and its primary defense mechanism. Probably all three at once. Designing for posterity is very important, and many a time architects tend to forget this. We use a lot of facade materials that probably do not age well. They look good, during a launch of a building, but then, the maintainability is not what was envisaged when it was installed. So that seems to create a problem. So designing for posterity and zero architectural Botox, although I know some people like Botox, but still, zero architectural Botox is very, very important in a country like India. Again, the harsh reality of maintenance. So, in Chennai, especially since land prices are so high, architects are always told after probably halfway through the project, whatever ideation happened at the beginning of the project, the client comes and tells you, boss, let's do value engineering, let's see where we can cut corners, so on and so forth. And most of the time, the corners are cut, in the facade of a building. So it's always imperative that an architect understands this from day one and designs a facade in such a way that it accentuates the parts of the facade that he wants to illustrate its character through. But at the same time, not look at materials that probably will not get used, and hence doing a last minute khichdi of the facade, so to speak. So gravity, pollution, rain, flooding, so many aspects actually affect how a facade reacts to various weather patterns in our country. So it's very important to take all this into consideration before actually designing your facade. Now, of course, I'm not going to talk about the larger projects here because I don't think it makes sense. I've probably taken three smaller projects contextually, projects that probably most of you who live in Chennai would have driven past, just to give you an idea about how a facade can actually correlate to not only the architect's vision but also the client's aspiration. So the first project I want to talk about is a holiday home. It's called Ananda. This is a client of mine who was a close friend. I designed his house in the city, which was more from an urban context. But this being a holiday home, he was a bit skeptical when to start, what to do. But then when they were on a holiday in Bali, suddenly his wife, after a few drinks, got this feeling that I need a Balinese style home, So she called me up at about 2 in the morning, my time. She didn't know what time it was there, but she called me up and she told me, PK, I need a Balinese style holiday home. I don't know what you do. And she sent me some picture of a resort that they were staying at. So let me talk about the design facets of this particular project as such. Does this work? Okay. So what we did was, basically the site is facing the sea. One of the biggest enemies of architects is Vastu. We all know that, right? So this site, actually, we had to orient the entire house, which is the main building in the southwest, which in a sense was not the most natural thing that one would do, but we decided to do it. What we did was, basically, if you see, the house is divided into 3 segments. The central segment basically is the public segment, where you have a double height living, and on the first floor you have a games room. Towards the east you have your dining room and the kitchen, and towards the west you have a bar and a guest room, and on top is again populated with bedrooms. So the spine of this project basically overlooks the swimming pool, which is actually the focal element of this project. The idea behind doing this was primarily because we could not get sea views at the ground level. There are, of course, buildings in front. So I wanted to make sure that the client has something impressive to see sitting in the living room, having a drink at the bar, so on and so forth. So the primary focal point on the ground floor is, of course, the swimming pool. Towards the east, we have one structure which is an open lounge. Now, this is also, I know that Chennai is almost impossible to enjoy yourself in an alfresco environment, but probably 2 months in a year we can afford it. So this is like, I don't think this works, but the one on the east that you see, that structure is the alfresco lounge. And towards the west is basically the spa, which again overlooks the swimming pool in a sense, but which is a bit more, concealed because of privacy and so on and so forth. You know that it's extremely hot in Chennai, right? So I don't have to tell this to anyone. So obviously we face problems where, we want this only, na? But I'm holding, it's nothing happening. Nice. Oh. Okay. Fine. Okay, so this sort of highlighter, right? Okay, so again, I lost my train of thought now. But having said that, basically we created the balconies towards the eastern side, so that it cuts off the harsh sunlight that's coming in. And that in itself acts as a facade element to the whole building. Secondly, if you see, when I show you the visual, what we tried to do was that when a guest comes into this property, he enters through this side, and once they get off, or there's a drop off here, you see the entirety of this facade. That was the whole idea. Because it's very rare that, when you enter a home, normally you will not see the entire home. But we wanted to make sure that you see this entire facade as soon as the guest enters. So that I feel is an entrance experience that's a bit unique. So the materials that we used, well, also, as I said, is part of value engineering. The roofing system, initially what we thought of was clay tiles, of course, on a framework. But then the client felt, no, I don't want to take a risk because Chennai, it rains a lot also. So, I don't want leakages, so on and so forth. So then we decided, okay, fine, we will actually continue with the slopes on the roof, but at the same time do it in RCC. But in order to save cost, what we did was, instead of using clay tiles, we decided to use shingles. The joinery that we used was again aluminum joinery. We made sure that, this being seaside, you have to use aluminum, there's no other go. But we got a light wood grained, grey textured aluminum profile. We used that in the facade. And all the other spaces which are really not that necessary, we use regular grey color aluminum. We use slate stone tile cladding on the ground floor because this area again becomes extremely dirty. It's used by the help of the house also. And during parties, it becomes sort of a messy area. So we made sure that it's a cleanable surface, so to speak. Again, we use aluminum handrails instead of going with the conventional wooden handrails for two reasons. One is that we want to make sure that it matches the facade of the 4 columns that we have shown in the balcony, as well as the joinery of the windows. And finally, in the lounge area, we used a GFRC column cladding. Instead of slate, even though this visual shows slate, but we used the GFRC column cladding done by an artist. It was an artist who came and actually sat at the site and constructed the, the design, which you will see in, now basically this particular visual is what I call a time lapse. A time lapse from when you ideate a project to when it is built. So the reason why I wanted to show this is that it's very important for any architect to understand that a client does not really want to understand the problems that you face as a designer when it comes to technical aspects of a project. So you show them a visual, and that visual, they think that it's going to come out exactly like that. But many a time what happens is, due to a number of engineering difficulties, it could not happen. So this small time-lapse video here is just to show you, this is the ideation, which means this is the 3D visualization till the completion. So this is the completed house. Now the reason behind showing you this is basically, the client was extremely happy that they got exactly what they saw. So that is one very important aspect when it comes to designing of facades. And I feel that, many a time it is probably not overlooked, but sometimes not really done due to a number of reasons. Moving on to the second case study. This is a bit different. This is basically a jewelry showroom on Anna Salai. It's done for a corporate jewelry brand called Vumudi Bangaru. They got this land after 23 years, and obviously they wanted to build something a bit iconic. So what we did was, basically they had their corporate branding philosophy was a temple, so basically, one second. So their graphic designer gave us this sort of a outline of a temple. I don't know, he says it's an outline of a temple, but this basically runs right through their corporate branding. So what we did was, we tried to use this particular facet also into our design. Now, as you know, jewelry shops, due to security reasons and due to lighting reasons, they don't like to have windows. A is basically, they have a lot of expensive stuff inside the store. Secondly, artificial lighting actually enhances the way any jewelry piece looks. So it was a bit difficult because you're designing a structure without any cutouts, So it was a bit challenging from that aspect. What we tried to do was, the easiest way to do it was just to do a cladding material right throughout the building from top to bottom. But that probably is the easiest way and not a very creative way to approach the problem. So what we tried to do was on the ground level, that is this, what you see here. Oh God, sorry. What you see here. On the ground level, basically, we created a double height, which is basically your main entrance experience as you enter the store. Then we have basically the first level and the second and third levels on top. Now the second and third levels are basically their executive offices and their accounts and so on and so forth, or whatever it is. So we did make punches for them on the western side of the building. I didn't want to make it in the eastern side, which is what you're seeing right now, because it would have looked completely odd. So what we did use was we decided that this is the eye view from the street, right? So this is what anybody can see from the street. So we decided that for the first 2 floors, we'll use travertine cladding, because that is again part of their corporate philosophy and branding. Then suddenly one unique problem occurred where this project is, you have the Gemini flyover right here, and you just come down here and on the left this project is there. So from the Gemini flyover, when people are driving on the car, they could see even this level very clearly. So we decided, okay, let us treat this level also a bit uniquely. So we used travertine cladding, and then we used some insets and created lighting there, so that sort of enhances the entire facade, so to speak. And then we added, after this was done, we added something. There's something missing. What to say? When you go to a party, you start off with jazz music, and then everybody goes on the dance floor only when Bollywood music comes on, right? So something was missing like that. So the thing that was missing was basically the Chettinad character, which is reflective of their brand, because that is where their family comes from. So what we did was we decided, okay, fine, we'll introduce 4 columns which are hollow, made in GFRC, just to enhance the overall look and feel and to give it the character which sort of aligns with the brand philosophy. So as you see here, we are given these Chettinad columns in various locations, as well as the portico. So if you see, the portico is the only area where you have a very large opening. Now, in this building, that is the only glass sort of zone that allows light in. So what I did was I made the door 16 feet high, gave large glass panels, because you need to have some direct sunlight also into the entrance experience. So what we did here was very unique, in the sense we built walls on either side of this, and we gave a huge door here which is 16 feet high, so that when you enter, you're entering with natural light behind you, and then you go left and right into the display spaces and so on and so forth. So we used also, actually we fabricated wall sconces as lighting, which also sort of elaborate the same design philosophy, as you can see here. So this was fabricated in Delhi. And all these panels that you see were made in GFRC as per their temple motif. So it was very simple. We could have done it even in marble, but it takes a long time. It's not a very workable material. So we decided to go GFRC and just go with simple painting on it, so that, at the same time, the colors of the paint are a bit unique. We have a red terracotta sort of color for this part of the design motif. And then as we go on top towards the 3rd and 4th floor, I decided that they need their corporate branding there, right? And they were very particular about the size of their logo. It's not that they said, okay, put the logo here, there. They were very particular about where exactly their logos fitted in. So we had the logo here facing the east, as well as the north and the south, but not the west. So we gave ample space based on their logo size, and made sure that we arranged these motifs on top and bottom of this logo in order for it to look unique. So again, like I said, this is again a time lapse. Of course, the building is still not 100% complete, but gives you some sort of an idea about what I was talking about earlier. So this was the actual ideation and the visualization of the project, and this is how it has come out. So if you see, more or less, I would say is 99.99% what you see is what you get. That is what I believe as an architect is very, very important to illustrate to the client as well as to complete the building in that fashion. So the third one that I'll go through is probably a bit of a different concept altogether. This was designed primarily as an office building. So initially when the site came to me in Alvarpet, it looked like, this would be taken by an office space or so on. But what happened is somewhere down the line, the project changed into something completely different, a beast of its own, so to speak. So basically the rentals that were being received for office spaces was extremely low. And the rentals that the client expected were only coming from F&B outlets. So we had to change our mindset also in how we look to design this particular building. I was lucky that there were a lot of trees here around the site, so we didn't cut any trees, thankfully. We had natural shading devices because of the trees, but there was a problem in the third and fourth floor of this building because direct sunlight from the west was hitting it. Now this is the west facade. I mean, honestly, it's a crime to put glass on the west, but you know how it is. This is basically a building that is supposed to be an F&B oriented building, a retail sort of F&B oriented building. So obviously, you have to have as much vision panel as possible. So what we did was we created basically a large vision panel base here. We have a slight curve to this simply because of the splay that we have on the road. What we did was, this was a basic core of the building with the 2 lifts and the staircase. And these areas are actually the service areas. Now, initially it wasn't designed like this, but obviously when you go for F&B, they're going to have large industrial kitchens. So we wanted to make sure that the kitchens are placed in the rear and there's clear uninhibited space in the front here with uninhibited views for the end user. In terms of material, like I told you, we use large vision panel which basically go from the skirting right up to the bottom of the beam. Those vision panels are 24 mm thick and laminated, but the spandrel glass we decided to save money, so we went with 6 mm thick because obviously they have a protective layer like a RCC beam behind them, so we don't need to spend so much of money. But what we did was, in order to counteract the issue of the west-facing sun on the 3rd and 4th floors, we basically did a very simple design of adding aluminum box extrusions in an interesting shape. So we had a shape already coming out of the building in terms of its curve, on the east and the north side. So we decided, why not create the shape for the shading device matching with the plan of the building. So this worked out well. This was all that I'm showing you are first attempts. I don't know why. I mean, I don't know AutoCAD. I have a few of my ex-colleagues here also. They know I don't know AutoCAD. I can't draft. I still sketch on paper. So honestly speaking, this just turned out really nicely. And then when we took it into 3D and rendered it, it looked iconic for a building of this size and this shape. We obviously used low-E glass, which is important simply because it cuts the heat coefficient as well as reduce the actual sunlight just passing. It's a very sharp sun, but the only advantage that I had is that, the sharp sun is between 3 to 4:30 in the afternoon. And luckily restaurants shut at that time. So, so from that perspective, I felt we were lucky in that sense. Most of the other spaces, we've used textured paint finishes. We didn't want to overdo it because again, most of the F&B outlets would like to have their own, display and marketing and so on and so forth. And again, this is a short time lapse, like I'm showing you. Of course, this building is covered with a lot of trees all around. So probably from that perspective, it's not as clear as the other time lapse, but it gives you some sort of an idea as to what I'm trying to get at. So this is the actual building. And this is probably at about 7 in the evening. So you have Starbucks on the first floor and you have a restaurant called Fufu and Jolly Indian on top. Again, like I said, from a climatological point of view, it's a bit difficult for architects to design purely on that basis when you have smaller sites. Why I decided to show you case studies of smaller sites is the larger sites have unending possibilities for your creativity. The smaller sites have to be done a bit more thoughtfully and in a sense cleverly also. So I don't know, most of you who passed by Alwarpet would have seen this building, and I feel like the client is extremely happy with the way it turned out, so are most of the users. Now, what is the anatomy of a smart facade? I mean, these are just words, but see, the climate resiliency again is dependent on how you look at a project. Sometimes you look at a project and say, oh, no, we should cut off all windows on the west, we must do only windows on the east. But it does not allow you to do so, because your planning will not support that sort of a concept. So you have to be a bit more flexible in the way you think. At the same time, you have to see how you are able to counteract that effect, like I showed you in the last building. Now, in terms of value engineering, see, all of us have a vision as architects, right? So we want to create an iconic landmark. Our building should be the best, our building should look the best, and we want to talk about it. All architects are egotistical bums, sorry to say. But end of the day, we have to be practical. See, in certain situations, you might end up spending more on certain engineering aspects and realize that you have lesser money left now for the facade. So you have to be fairly clever in how you utilize the money of, the project outlay, so to speak. So substitution of materials is okay, as long as it does not compromise on the overall look and feel that you wanted to achieve from day one, right? That is very, very important. And then, of course, is the narrative identity of a project. See, every project actually is very aspirational for its client, right? So every client has different objectives, which they want to achieve from the project. Some clients come and tell me, boss, I just want one glass building. It should look like an international building designed by a Singapore architect. But that's very easy. You give them whatever it is, as long as it looks good is fine. But most of the other buildings, which are the smaller buildings, actually you have to really think about how you are able to bring your creativity to life through it. So at the same time, maintaining what brand identity the client wants to express through that building. So it's a tough call, but having said that, we all have to try. That's all I can say. So I'll keep it short. I think already it's late, but I'll keep it short here. It's not easy for architects, like I said, but the only thing that keeps us going, getting up every morning and going through the rigmarole, is that we have the opportunity to create something new every day. So with that, I can take your leave. Thank you so much.
Thank you, sir, for taking us through your phases of architecture. Next on stage is Mr. Abhishek Shukla from Technoform.
So good evening, everyone. I guess I'm audible. In case not, I'll try to be a little louder. I'm from Technoform. We deal into concept related to thermal break. Since morning, we are in discussion about for topics like energy conservation, sustainability. We as a company will speak more about the concept. I'll try to keep it a little short, and we'll focus on what we do, how we do, and why we do, and what is the importance of thermal break with perspective to Indian market. As the first slide always says, we prefer to talk about the solutions. We are not here to sell something or pitch in something. We always prefer to go with the design, with the consultants, with the clients and everyone, all the key stakeholders, to speak more about the solutions what we go for. I'll request for your attention for an AV, a short AV, that gives a brief about our organization. Idea is to just to give a brief what all we do. We know what we are facing around, what is happening around us. It's related to the scorching heat. We recently saw in Europe there is a sudden rise in the temperature. India, anyways, we are bearing all these temperature variations. The Himalayan snow cover, the global warming again is also affecting drastically to our climate. Middle East crisis are spanking us a lot with respect to the fuel prices, and electricity bill may also increase soon. We are hearing soon a rise in the power outage or something. So Middle East again, the energy spurge in the ears, and believe me, these all things are affecting our overall India growth with respect to facade and fenestration. So why Technoform is discussing here, what we do actually for facade industry for India and globally. We provide solutions related to thermal break. Okay, so first one is the thermal break. We deal into concept where we specialize in providing solutions related to thermal break, the strips, the material with the polyamide and everything. Second is the warm edge spacer, catering the requirements of the condensation problems, specifically the coastal areas, the projects in the coastal areas. So we'll speak about these two concepts in brief. So we all know where the heat is coming from. As of now, everyone speaks about the center of the glass where heat is actually penetrating, but we have a different concept on that includes the glass part also. If you see, we have three markations done, SP1, SP2, and SP3. The SP1 is blue because the heat is less, the sunlight is less there, so that's why it's blue, more of the heat is coming into the building. SP2, yes, it's more of heat coming, that's why it's red, and more of energy exhaustion inside with respect to AC and everything is more there. But if we focus on SP3, that is the edge of the frame. There is actually the problem comes and where we bang into the solutions that is related to the covering the edge of the frame through thermal break. Here, actually 85% of the energy is penetrating into the building. It's a nice office building. We have spent, a client would have spent a lot on facade and fenestration, but he would not have heard or thought about how the energy would be coming into through the frame. What solutions we give? We give solutions related to insulation, and in insulation particularly we focus on polyamide. And why polyamide? Because of its features. They are sustainable. They help out in saving the energy 500 times. Same rate of expansion and contraction as to aluminum, which other material definitely cannot go for because of the temperature variations and the change in the climate. High melting temperature because other material cannot sustain the temperature up to 250 to 60 degrees where the extrusion or powder coating is being done. Fire resistant, we are speaking or discussing a lot of fire. The recent changes in the National Building Codes also speaks about the fire resistance. So our product, the material is all fire compatible. For architects, where they speak us a little more about with us is related to the color profiles, where they want inner thing to match with the intent of their interiors, and they want the aluminum part to be painted with the inner interior thing. So we have a compatibility with our strips that can sustain to bicolor profiles also. Recyclability, 100% recyclable. The product is 100% recyclable, polyamide PA 6.6. Second solution, as I spoke about the condensation part, which we feel more in coastal areas, Chennai, Mumbai. We have a solution related to edge-bound solutions where when we pitch in warm edge spacers, that take care for solving the problem related to condensation. We propose these things to be as a replacement of aluminum, traditional aluminum spacers. And aluminum spacers, why we go for this? Because the challenge what we get from the consultants or clients or architects, heat gain through the edge of the IGU. So if we look for a frame, there are three parts where the heat is actually penetrating in is one is center of the glass, edge of the frame, and edge of the glass. So here we speak more on edge of the glass, where the thermal conductivity of aluminum is anyways 160 watt meter Kelvin. And what solution we provide is warmage spacers made of polypropylene. That is the material itself signifies its importance. This is the difference. Traditional aluminum spacer, the linear thermal transmission is of aluminum spacer is 0.16. And if you see there is a reduction of 44%, Technoform thermally improved spacers have a thermal linear transmission of 0.09. So this is a significant difference which helps us out in creating the atmosphere feasible for the client, as well as reduction in the condensation and HVAC load. Sustainability, we are very much closely related to sustainability. Our products are all EPD compliant. We are closely working with vision of Government of India related to neutral carbon country. We are aligned with their mission and vision, and Technoform is leading the flag particularly and getting associated in the working committees and in the working closely with the government and allied agencies related to promoting thermal break as an overall concept. So we are cradle to cradle gold certified, our products. We have passive house certified for A class and as well as B class, that comprises of overall temperate, cold and arctic climate across the country. We are members of Glazing Society of India, which are closely we are working related to codes upgradation with respect to national building codes or ECSBC with Bureau of Energy Efficiency. We are member of GREHA. We provide our solutions, our concept to these allied agencies, wherein they work together with the developers, consultants and architects for the products. This is a recent update we managed after working for almost 2.5 years with BIS and other allied agencies. Earlier, there was no concept of thermal break discussed in National Building Codes, and since now, National Building Codes has changed to National Building Sustainable, the construction standards. The polyamide strips, thermal break concept with polyamide strips have been included in National Building Codes, the updated one, and we are proud to make it a little more appear in the market, and let's go for using it judicially. These are the green building certifications which our product handle, which we have. So we have been speaking about the solutions and everything. We provide the consultancy services also to the consultant, facade consultants, clients, architects. With respect to thermal calculations, I'll just take 2 minutes more. With respect to thermal calculations, specifications, driving a BOQ for facade, submissions and everything. Quickly, I'll go through the sample simulation, how we submit the calculations to the client. So our objective, the client's objective was to achieve overall curtain U value of 1.6 or less. So what we did is, we introduced first the insulation part, that is the polyamide strip, using 30 mm C-shaped thermal break, and which has an average U value of 3.15. We introduced the warmage spacers along with the system, the 30 mm C-shaped thermal break, so that we can achieve overall U value of less than 1.6, that is 1.59. We are energy saving. This is a case study we did. I'll quickly go through. Here I'll just brief. We did a case study, not in India. It's a for Bahrain project. We considered 500 villa sample project, where we considered the parameters of maximum temperature, difference from comfort temperature and maximum temperature, energy loss to non-thermal break windows, and energy loss to the thermal break windows. These are the parameters we considered. Here we maintained a comfort temperature as communicated by the client of 23 degrees. What we got is the comparison. We showed how the blue bars, how they are rising in the energy conservation, and the green ones. But still, we have a booth there. I know we are running short of time. So we have a booth there. We can discuss in detail a little more. Yeah. Thank you so much.
Thank you so much, sir. Next up, we have our second panel discussion. I would like to welcome our moderator, Mr. Sri Krishna, Head of Facade on L&T Constructions, and our esteemed panelists, please.
Good evening, everybody. Am I audible to all? All right, so I guess we are the last on this day of event, and I just have a small request. Can we all stand up for 2 minutes? I want the national anthem to play now, please. Everybody, please. Just for 2 minutes. Okay. All right, thank you. I was just kidding, okay? You can sit down. I wanted everybody's attention here, and I don't want you all to go to sleep, okay? So before I start, I just have a small question before I get to this business. How many of you all have watched this movie Dhurandhar? You can raise your hands. Lots of them, okay. So there's a punchline or a tagline in one of the songs, you know. It says, ladies and gentlemen, you are still not ready for this. For this, okay? So I think this aptly suits our panel discussion and the panel. I'm quite honored to introduce my panel today, evening here, and I'll start with the ladies go first. Ms. Shruti Reddy, she is an architect herself, right? And she's also one of the largest developers of this region here. Mr. Vijayan, he is the chief architect, he's my colleague at L&T Constructions. Mr. Ajay Sethi, architect Ajay Sethi, very renowned, prominent architect, having offices in Bangalore, Chennai, and in Singapore. My friend Rohit Sharma, he is the CEO of Innovators. And last but not the least, Mr. Pratik. He represents Shuko. So we'll get down to business, and the subject that we're discussing today is on the facades from concept to delivery, okay? So I think I'll also have a seat and I'll start posting my questions to my eminent panelists here. So I'll go by the book because most of the guys would be reading out of this. This will be easy for us to also correlate. So when we talk about facades from concept to delivery, we talk about concept, and that concept starts with an architect who is the torchbearer, the visionary. We all follow his vision, and my first point of discussion is probably addressed to you, sir, is about your views on how you design facades, taking into consideration the functionality, the performance, the constructability, and obviously the budgets. So I would like to have your views on that.
So interestingly, we don't design facades, so it almost sounds like I'm the wrong person on the wrong panel. But to elaborate on that, as architects, we design buildings from inside out, not necessarily outside in. So the approach is different. We look at buildings for what they are, and the layouts, the functionality, all of that impacts what you see outside, the envelope. So the envelope is not a cosmetic application, but it's more, I would say, an active performance layer that is driven from the inside.
Right.
So that's how we approach any design, and then with the help of all the stakeholders in the act of putting together something like this, and that includes all the members of this distinguished panel. We all come together to finally realize that into, let's call it a facade for now, for this panel discussion.
Right.
But as architects, we're looking at form, functionality, light, but we're also looking at maintenance. We're looking at operations, things that I'm sure this panel will talk about, during the course of the time that we have. And how does all of that come together in what we see as the final built form?
Right, right. Ma'am, would you like to add something to this? As an architect or as a developer, I mean, you wear two hats at the same time, so you could answer it whichever way.
So I think one about constructability and conceptualization is collaboration has been the key now. And I think early collaboration before you begin to really develop the project, be it with structural engineer, the consultants, the contractors, specialized contractors. I think that's very important to really optimize the building. And I don't think budget I would call a constraint, but I think it's more how do you optimize the budget and where do you see the value. And I think that's where the facade becomes really important, right?
Right.
Because I think in premium commercial or luxury assets, the facade is the face and the
Right.
identity.
Yeah.
And it's important when you have a high performance facade, there's definitely better superior acoustic comfort, better optimization of daylight,
Right.
and that definitely affects, one, I think premium rentals, the sales
Yes.
is
The
definitely,
ROI is basically.
there's where you see the output, right? And of course, I think also translates into asset valuation.
Right, great. I mean, the good point that you made, and I really appreciate you for that, is about the inclusivity. I mean, having all the stakeholders on the project right from day one, makes it more, I would say, feasible. And the other thing that you said about the facade being like, there was architect Mr. Prashant Kharche. He made a nice statement during his speech. Was he said facade is the personality of the building. So, like a lot of people talk about facade as aesthetical or a cosmetic look, but he said he used that word personality, which is a very nice way to put it. So, I guess that's what you meant. Well, coming from the performance-driven strategy, etc., that we spoke about, the next obvious question comes to is about evaluating the performance versus the budget concern. Again, that is more to do with the developer, but of course the architect's vision should not be compromised. So how do you kind of evaluate that, or how do you bridge that gap, or what are your thoughts on this?
Like I mentioned, I think optimizing value, when you have everybody at the table aligning with the design intent, it's much easier to come up with a solution. And I think in terms of constructability, I think today, 15 years ago, Chennai didn't see the kind of skyline we have.
Right.
I also think that's really changed because I think our local availability of the best talent, we
Yeah.
have the best solution providers, we
Right.
have structural engineers, we have contractors. I think that's really helped to a large extent.
The ecosystem that we have.
That's really matured over the
Absolutely,
years.
yes. So, Vijayan sir, I mean, you again also wear two hats. You're an architect yourself. At the same time, you represent a large organization like L&T, which is into construction. Since I'm your colleague, I know more about her business. You're more into contracting and all that. But you also have a very difficult job in terms of, dealing on this subject like an architect at the same time as a contractor. So, how do you look at this performance requirements or the specification that our clients come up with, and then the budget constraints that we have? Because we as contractors need to, kind of encompass the delivery within keeping the specs intact as well as within the budget. So, you have any views on that?
Obviously, I feel being an architect as well as being in a construction company, it's not a constraint. In fact, it's a boon because I can see both sides of the coin in terms of what is the vision of the architect. So we don't try to sort of challenge the architect, but align to his vision, and also in terms of the client's requirement, in terms of the operational efficiency, what they're looking for. So whenever we get a project in hand, during the tender stage, we try to analyze whether all the aspects of performance, maintenance, in terms of the vision of the thing is being taken care, and also in terms of constructability. And then we make sure these things are being inquired, any gaps being felt in the tender documents. We try to sort of ask us a query so that all the stakeholders can respond to these queries, and we can accordingly cost the project. And nowadays, a lot of things are, because client also get funds from different agencies, banks, and other things, who are also insisting on green building ratings, or Griha or EDGE, World Bank, and all, they insist on EDGE certification. So we ask the client whether they are going for a sustainability point of view, so that based on that, the client can decide upon the performance requirement.
Right. Ajay sir, you have any views on this, because this is again to do with the budget constraints that your clients or your developers could have vis-a-vis the kind of specifications or performance requirements that you could have kind of laid down for a particular project. So what are your views on the challenges that you
So that's something where I think collaborative work comes in again.
Right.
So what we present initially is a broad brushstroke of something that we want that takes into account all the factors that we believe are important when we work on a building. But it's when we start working with our consultants, when we start working with facade consultants and with contractors, that we really begin to see the role of specifications in aligning the original vision to the client's, let's say, budget or the project budget. And how that can be done in a manner without compromising the quality of the product or the system. Because the facades are complex systems. Even one element goes off can lead to water ingress or air leakage. So how do we keep a comprehensive and complete system without letting it break and fall apart when we get down to the detailed aspects of the project? I think that comes by working closely with collaborators on specifications and substitutions rather than value engineering.
Right, right. I mean, I was coming to that subject or that question in my next thing. So basically, we spoke about design. We are talking about how we evaluate the gaps between the budget and the specification, etc. And coming to these gentlemen here, who eventually are the end delivery guys, I would say, I mean, who put or who bring to reality your vision or the developers' requirement to on the ground. So, Rohit, what is, although it's mentioned as risk, but it is not a risk, but what are the challenges that you feel, like what Sir said in his last statement about value engineering? I would call it value addition. So what do you look at, or what are the challenges that you face in terms of approaching this subject when it comes to value additions or value engineering, or any substitutions or any alternate things, keeping obviously the architect's concept, the specification requirements intact? Do you have any challenges, or do you come up with something which is appreciated, or how is it?
Thank you, Mr. Shri. Actually, it's a very important question. Everybody faces this challenge on a daily basis, I would say. Anybody making up a project deals with three important factors to deliver a job. One is time, quality, and cost. We need to prioritize two and work on the third one. What happens is when we take care of these three factors, cost is a factor which you can account for when you are actually paying the bills. Time is a factor which you can account for when you are working on the timelines or the deliverables of the project. Quality is a factor which can only be defined post the delivery of the project of post 2 years. So we need to keep that vision in mind, that the things which we can ignore during the execution of the project on the drawing board when we are collaborating. So when we talk about value engineering, the true sense of value engineering is the value. So when we talk about just reducing the cost of the project, that should not be the vision. Value engineering is a very important factor when we say that we might have over-designed something or we might have over-estimated something when we have a look at a drawing at the first glance. So I think collaboration with expertise of a structural engineer, of an architect, of a material provider plays a very important role, and I would say that it's one of the most important factors to deliver a job. The only thing is it needs to be set right, and it needs to be set right at the first go. So as ma'am mentioned, collaboration early will save us all the time, and we would be able to capture all the three aspects of the project.
Right. So Pratik, the same question to you, because you come from a very different background in terms of complementing our business, which is to do with engineered or well-designed products. So you spend a lot of time in designing a certain product. You come up with a platter of products that you have on board. So, I mean, what challenges you face? Because a lot of time we could have requirements of a bespoke system or something like that, or a tailor-made system for to suit a particular thing. Whereas you come with a platter of or a bouquet of systems which you already have designed. So how do you overcome these challenges, or how do you address these challenges in terms of value additions or value engineering, or substitutions?
So we get a lot of requests of doing some value engineering over someone's specification already set. So as Rohitji rightly said, value engineering is possible in a project where there is a scope. Value engineering is not doing compromises.
Right.
So a lot of people say that you tell us about compromises, we are okay. You tell us about it. But we don't like to take that approach. We like to keep the building's life intact. Okay. So what is the building? Because we have a tagline we follow. We work for the end user. We work for the outstanding building. So if someone is asking you to cut corners and make a building, then we were never meant for that building. And we have a process to work on that. Even if it is value engineering, we first take the specification and go through the structural route. When the structural engineering tells us that yes, there is a scope, okay, then we do that. And changing the stack height and all that, that comes only after discussion with the architect, because we do not even change the architect's intent, because the building line is something which he has designed after some thought. You can't just add your engineering and make the building line whatever you feel like just to reduce the cost. So these challenges we come through, we take a road, we have a process, and then we say that this is how we can solve or we cannot. This is the only reply.
Okay. So sir, Ajay sir, like I said, they are the end delivery guys, with having their own challenges to do with end deliveries. But having said that, and having also spoken about a cohesive or a collective, kind of start to a project by inclusivity, by involving all the stakeholders, yet there would be challenges when you actually get onto the execution stage. So how, I would say, I don't know what's the right word, but how open are you to this kind of suggestions or any kind of substitutions as an architect? I mean, of course, not compromising your intent, but let's say in terms of, like he said, he's got an engineered product, but he probably would have a certain width or a depth of a profile, and he would not be able to, kind of change that. So how open are you, or how do you look at this kind of a challenge coming to you? I'm sure you must be coming through these challenges.
All projects come with challenges, so that's that's what we're all there for. So each of us solves those challenges in different ways, and you made an interesting point that what we do is we typically start with what you don't see.
Yeah.
So you've got certain elements, you've got certain materials, but you've also got the structure that's holding that up, and that is where you relook at those structural calculations, and we've seen invariably there's a lot of savings in what's behind the scenes. So that is number one, and obviously that is most welcome for all, right? Because that's an element that you don't see, but it's sometimes over-engineered, and it always helps to ask the question why. And when you do that, and then when you relook, you look at the number of mullions, you look at the size of these mullions, you look at all the steel that goes behind supporting these envelope or skins. That's the first area where we look to save, and everybody is happy at that point. But then, there is always, you need to continue to ask that question why when you go through your bill of materials. And it makes sense sometimes to substitute one for another. Now, there is no one way of getting things right. Sometimes you take a decision. When you review it with everybody, you realize that you could do this differently. That could bring down the cost. And we're always open to doing something like that. But of course, keeping our when I say vision intact, we can work with different elements and still make it work, so to speak.
Right. Yeah.
And that is always an important part of the process of getting to the final product. And the earlier that the stakeholders get involved in the project, the quicker and the less painful this process is, because you can actually dictate or change stream a little bit while you're still in the process of developing the drawings, the tenders, and all of that.
Right.
So the earlier we do this, the better.
Yeah. Great. Shruti ma'am, the same question to you, but in a different way as a developer. So you said some time back about how we have in Chennai evolved over a period of time, the landscape that we have seen, the skyline that we have seen here changing. So this is more specific to challenges within Chennai. So let's say you have a project as a developer, and we have people who are mostly coming from outside to deliver it. So the ecosystem probably doesn't support them in providing what you're looking at per se regionally, but they could come from an international kind of a standard or from some, let's say, from a national standard from wherever he is coming, having done a project somewhere else. So he's coming from his comfort of an ecosystem that he works in, and then he has to deliver something that you want to have it in a particular way here as a developer. So how open are you to accepting these kind of changes, and how would you deal with an architect? So this is basically, I'm pitting you against him in terms of addressing it as a developer, and your thoughts on this.
So I think, earlier material availability also and the systems available in the market were limited. And talking about how do you optimize or, suit to save a little bit and optimize the building, as long as we work with certain modules, optimize wastage, I think certain things get adjusted when you work with the system supplier and the designer, right? Today, I think there are certain things that are in control. Earlier, most of our systems were also imported, lack of availability. Today, there's a lot of domestic manufacturing. I think we have the best aluminum, composite panels that are manufactured in India.
Correct, yeah.
There are aluminum honeycomb panels that are manufactured in India. Glass, I think all kinds of.
Base is in Chennai.
Yeah, it's all available in India. So I think that has drastically reduced our dependability, be it logistics and all of that is taken care of. So I think we're also able, today timelines are the most important, right?
Exactly.
And the other thing that's really helped, I think delivery is also using tools to kind of, whether it's BIM, whether it's other tools that you can visualize to see how effectively can you integrate these into the system itself. And thus, not really seeing how it works after the building is constructed, but also before you really get started on the project. So I think all of this together has helped our industry drastically, also in terms of predicting timelines and deliverables.
Right.
Just to add to that, Shruti, you mentioned tools that are available to see what you're going to build. I still feel that we need more tools. As architects, especially when we talk of envelopes and performance, we don't have enough tools to take key decisions at the beginning. When we're talking of massing, orientation, energy performance, we are still dependent on a consultant coming in, let's say a lead consultant coming in and giving us the metrics. Typically, it's too late by then. Nobody wants to change the orientation of the building 6 months down the line, which is when the lead consultants typically come in.
Right.
So in fact, we've been wanting to develop custom tools that architects can use at the design stage itself, when it's still a block, to take key decisions which will then make, serious impact much further down the line. And that's something that we have not, maybe there is something that exists, I'm not sure. Happy to learn about some of these things, but we haven't found anything that we really integrate into the design processes yet.
But I think what is important is to add, the reason I say they are tools is they cannot overtake what you imagine, right?
True.
And I think they're purely used as a tool. So the architect will never, I think, go out, everybody talking about AI, giving you everything that you need to build a project.
Yeah.
So I think these are purely tools, and it's how efficiently you can utilize that into work.
Yeah. Now you said the word AI, so this panel is going to get derailed completely.
Yeah, so before we get into AI and stuff like that, I would like to again get back to facades. And Vijayan sir, do you want to add something to what they said? Because as a main contractor, again, like I said earlier, you have dual responsibility as an architect as well as a main contractor, because we also have the responsibility and the onus of sticking to the specifications. But we come across a lot of projects. We do a spectrum of projects, like we have airports or bullet train projects and things like that. So we come across a lot of specifications and things like that. So what's your take on us giving as a contractor, as a value engineering proposal or substitutions? Again, keeping in mind the intent, the vision, etc. But like ma'am said about delivery, which is very, very important. So we have to come up with substitutions or with kind of any suggestions which eventually are going to deliver the project timely or whatever. So you have anything to say on this?
Yeah. See, compared to the rest of the world, our facade system in India is quite new, because first facade system in India came in 1953 only. But the European countries and they started in 1800. So during this period of time, the global market has evolved itself. They have different standards for testing in terms of different systems and other things. So which our market still is not available. So in the client side or the architect side, those things are not being fed into the specification. When we, as a contractor, when we get the package, the specification is not clear in terms of what standards to be followed, ASTM, AMA, or Indian codes. Those are really missing. And in terms of the support systems also, like obviously Mr. Ajay was saying, like a lot of structural steel is going to go behind the mullions. But what is the system? Whether you need MS, you need GI, or you need some sort of a powder coating system, or you need a PU coating or epoxy coating. All these things are all question marks when a contractor gets his specification. So, and it's difficult to estimate, obviously to estimate and give a fair pricing to the client. So these things and these such forums like this will be an eye-opener for all the clients as well as the developer to educate themselves and come out with this system. Because we have good international facade consultants, we have good system integrators and available in the market. But there's a gap still existing when we get specification from the market.
Okay. All right, fair enough. All right, so I'm coming to the last point. I mean, we discussed everything right from concept. We talked about the budget constraints, the substitutions, the alternates, etc., etc. Eventually, it comes to you guys to deliver on the site. So after having gone through the whole process of designing, negotiating, coming to a budget, coming to everything, economics and all that, you eventually come to delivering the project. Okay, and it requires a lot of, I would say, effort, right from the stage of design to on-site execution. So what's your approach on any project in terms of whenever you have, like we were discussing with ma'am some time back, and they're doing high-end luxury, let's say residences, sir is doing a lot of work, they're doing a huge spectrum, which I was talking to him separately, from data centers to hospitality business, etc. So every project requires a different approach. But there are certain things in common, which is like design, your quality in design, your quality in production, execution, etc. So what are your challenges? What is your approach? What are your thoughts on this? Purely on delivering a project.
So I think for a good quality product, we need to work on the knowns and we need to avoid the unknowns. I think that's a very simple concept. Once we have things on drawing, on paper, agreed by all the stakeholders, that is the first step. And if the drawings are signed off, just not an autograph, but every detail has been checked, probably a mock-up done, and everything visualized in terms of what the mass production will look like. That's a big no. Then post that, elaborating this concept to the team, right from different stages, from the designing, from the manufacturing, to the manufacturer who provides us the raw material. The knowns would help us make sure that everybody has the same vision, and then we deliver. I think facade industry is not as complicated as it looks, as long as you have more knowns and lesser unknowns. The biggest problem happens only during an unknown. So I would say that in general, everybody being on the same page, everybody agreeing to the final goal, and addressing problems as it comes, because we have a lot of cyclic problems. We have labor issues, we have weather problems, we have all these. So knowing those problems solves the problem. I would say that if you know there's a weather problem, you need to have extra days to cater to. You know that labor count is going to be less, you will have lesser productivity. We do not compromise on the final delivery of the product just because we have less labor. So I would say it's a very simple thing. More knowns, lesser unknowns.
Great. How about you, Pratik? Or do you complement what Rohit says?
What he said is very if you don't know a few things and you are moving ahead in the project, you are planning for many wrong things to happen. And those wrong things will delay the project. And the developer at that time will be actually, will be looking for an ROI, and the project is not ready. So that's a very, very difficult situation, and you can't explain your problems to the developer at that time because they have even a bigger problems at that time. How we take care, see, quality control usually is considered that it's a site execution thing, okay? But it is right from the design. So when we get a tender or we get a concept drawings, we start designing, we check the serviceability, the how big is the glass, is the building having PMU? We need to talk to the customer that you cannot have such kind of a big glass or you cannot have such kind of big mullions. The glass is not replaceable because you are having such very big kind of fins. What are you going to do in this kind of situations? There are conditions with many things. There are conditions in corner areas which are the most critical, and they are designed to keep it more aesthetic, which is not serviceable, not maintainable in future times. And those corners usually I have seen building.
This was a signal for us to end the meeting, looks like. Sir. Check.
This happens whenever we corners.
No. You can continue, yeah.
Hello?
Yeah.
Hello, yeah. So I was talking about that part, that corners usually fail in the time of PMU test. I have seen a lot of people go for testing and the corners fail in the water penetration. This is because that all the part of design is not taken care. There has to be a process while designing. Not everyone designs the way it has. There has to be a process and has to be religiously followed, even if the project is smaller or bigger. I myself, in 13 years, I have learned this hard way. Okay. Hello. Yeah, I have actually learned this very hard way, that taking shortcuts actually affects the projects a lot. So we follow the process in such a way that we design, then we do the structural check. We send the drawing to Germany for a fitment check. The Germany says that this profile is right. Then we send to the extruder for the extrudability check, and then the profile is fine. That's why it takes a hell lot of time actually to get something new made out of Shuko actually. But we're trying to reduce it as much as possible as we have the R&D facility. Second thing, what we do for the residential buildings, a lot of time we have the water penetration things. A lot of buildings are coming up with different designs. So we started with a test rig over here just for water and air. We don't do completely third party thing, but only for water and air we do our part of job, and then we go for the third party. Because we do a lot of permutation combination at our end only before we come up with a slider and go to the PMU for the final test or offering someone. Because 1000 Pascal is the requirement today. So if you have to push that much water out and have that much pressure head, you need to have a process, otherwise everything is haywire. Because working on multiple projects at time and giving the same quality output, that's a challenge.
Right.
Thank you.
So Shruti ma'am, I took a cue from what you said in the end, and we were discussing outside about testings and things like that. So I just wanted to have your views on facades during the execution stage. You must have, as a developer, come across situations or challenges, So what's your take on any contractor who comes to execute facade, and what challenges have you faced during those times and the testings that he was mentioning? I think we also spoke about it some time back. So you want to add something to it about how, as a developer, you would want somebody to approach your facade and execute it?
I think, talking about testing, about 15 years ago, there were, I think, a handful of testing facilities that basically took care of everything, right? And we didn't have any in Chennai. I remember one of the projects we were working on with Shuko, we actually had to do it in Bombay at that point. Today, you have an access to everything locally. And I think almost all premium developers definitely do a full-scale physical mock-up and make sure that you're testing for all, whether it's static, dynamic, water ingress, and seismic as well. So I think that at the initial stage definitely also helps to kind of, fix all the problems that you might foresee. So that's something that we've learned and we've been following in most of our projects.
Great. So I guess that brings us to the end of this question and answer sessions. In case anybody from your end want to add something to the session, or then I would invite the august audience here to come up with any questions that they would want to ask our panelists. and anything that we have missed out on or anything that you would want to understand from them, and you would not find a panel like this, right from a developer to a main contractor to an architect to a system designer and a facade contractor. So if there's anything that anybody would want to post a question, we are all open, right? Suresh sir? All right, then thank you so much, ladies and gentlemen, and it was great having you all. I hope we were in time, and thank you so much for being patient with us. I thank all my panelists. It was a really an interesting discussion. I think we should take it to the next level. Maybe we find another platform to have this kind of discussions again. So I would also like to thank Zach for having us all over, and not to forget today's Ahad's birthday. I don't think he's here, but I wish him happy birthday. And God bless him. He's not here, right? So, okay, all right. So, happy birthday, Ahad, once again. Yeah. Thank you so much, audience. Thank you so much.
Thank you.
So,
Yeah.
sorry? That we won't go without it.
What a great session and a great end to a long and inspiring day for all of us.